Okay, so welcome to the mega marathons for GATE 2025. So in the last 2 days, I believe you have completed the control systems discussion of marathons. Now in this session as well as in the next session, we will discuss about EMF, and specifically in this session, I will be focusing on a few areas of EMF. Okay, so these are some of the areas that are important for the GATE exam. So yeah, we start with certain background. The background is very important in EMF subject. Without background, moving forward is not easy. Not easy to solve any problem also in case of EMF. Okay, so yeah, we will discuss a few background concepts like what are the ranges of coordinate variables we have in all the three coordinate systems, that is rectangular, cylindrical as well as also in spherical. And after that, we will also look at the point as well as vector conversions. Okay, we will look at point as well as vector conversions, and lastly, the most important part, we will look at the differential parameters. Now these differential parameters are very important if at all you want to perform line integration, surface integrations, volume integrations, etc. So these are the things that we will discuss. Okay, and then we will focus on initially the vector calculus portion, gradient, divergence and curl. And if you look at every year, I have taken them in pairs. Forget about the first point. Remaining points are taken in pairs. Divergence theorem as well as Stokes theorem. Every year you are having one question, at least from one of them. Mostly Stokes theorem. This is one of the most important areas. And from divergence theorem and gradient combined, we'll get one question, alternate years. Okay. And then Gauss law, Ampere's law. Again, this is one more pair. Sometimes you get two questions from each of these topics. Sometimes you get only one question. But rather again, this pair is again very important. And then the pair of solenoidal fields as well as conservative fields. 100% damn sure question. 2024 EC paper, if you see, we have got question on both solenoidal fields as well as also on conservative fields. Okay, so we have got a question on both of them. And then point charge as well as line current scenario. Okay, one each in case of electrostatics as well as magnetostatics. Point charge scenarios, what is the electric field because of point charge, what are the potentials because of point charge, etc. And yeah, a few problems on point charges, and then line charges. Okay, sorry, line current. So what is the magnetic field intensity as well as flux density due to a particular line current, and given a scenario, how much amount of flux flows through a particular surface, etc. So these are the kind of questions that we generally get. Okay. Furthermore, when it comes to Gauss law and Ampere's law questions, apart from knowing what is Gauss law and Ampere's law, we have to take two important scenarios. One is nothing but spherical volume charge density scenario, and the next is nothing but the cylindrical volume current scenario or volume current distribution scenario is what we have to discuss. Okay. Yeah. Next. Yeah, coming to the first coordinate system, which is rectangular coordinate system. In rectangular coordinate system, we have three variables x, y, z. Briefly, x is nothing but distance of a particular point P from yz plane. So this is basically the distance of a point P, basically from yz plane here, and measured usually in the positive direction of x, and y is nothing but distance of a point P from xz plane, and lastly z is nothing but distance of a particular point P from xy plane. Okay. And furthermore, coming to the ranges of xyz, the range of xyz in fact is from minus infinity to plus infinity. Okay, minus infinity to plus infinity. And from exam point of view, nowadays at least if you see, most commonly we are getting questions from other coordinate systems. Okay, other coordinate systems. The second one being cylindrical. In the cylindrical coordinate system, rho is basically the distance of a particular point P from z axis. So let's assume I am the z axis. So away from me, how much is the distance of a particular point away from z axis corresponds to rho. So this is the distance from z axis from z axis, And on the basis of this, whenever I say rho cap direction, rho cap is the unit vector in the direction of increasing rho. So rho cap direction is radially away from z axis. Okay, so there are two radial directions in our course. One is basically rho cap direction, one more is r cap direction. So in this context, rho cap corresponds to radially away from z axis. Okay, and similarly phi is nothing but angle made by, this is basically angle made by OP dash, where in this context P dash corresponds to P dash corresponds to the projection of point P, on the xy plane. So you have basically some point in space, some random point in space, you are taking the projection of that particular point P on xy plane, wherein the floor plane is nothing but xy plane. So angle made by that particular OP dash line segment with respect to now x axis, corresponds to phi. And similarly, what is phi cap? Phi cap is also unit vector. So phi cap is the circulating direction around z axis. So whenever you have taken a z axis and you have taken a circulating direction around that z axis in the anti-clockwise direction when seen from top, when seen from positive side of z axis, corresponds to phi cap. So in short, we can say phi cap is nothing but circulating direction. Okay, so this is basically the circulating direction. Circulating around what? Circulating around z axis. And anything with respect to z remains the same as compared to what we had in the case of rectangular coordinate system. Okay, so this portion same as cylindrical coordinate system, right? Now coming to ranges, in case of cylindrical coordinate system is very important. The range for rho, what is the range for rho? For rho the range is from 0 to infinity, and for phi examiner will not give you this range of phi, that is something that is assumed basically in coordinate systems. The range of phi is from 0 to 360 degrees or 0 to 2 pi radians. Basically you are circulating, okay, you are doing a 360 degrees turn around the z axis, means obviously the range is 360 degrees, and for z it remains the same as compared to what we had in the case of the rectangular coordinate system, which is from minus infinity to plus infinity. So this is regarding the ranges of the rho phi z. Main part here is nothing but ranges. You have to know what are the ranges of mainly the angles. First of all phi, the next one is nothing but theta, that we will discuss next in spherical system. Okay, yeah, in spherical coordinate system now we are having r. R is a r is the distance of a particular point from origin. So in case of spherical coordinate system, the reference is always origin. So r corresponds to distance of a point from origin. Okay, and coming to theta, understanding this r theta phi is very important. Theta is nothing but angle made by, this is basically angle made by the OP line segment with respect to the positive x axis, sorry, positive z axis. Okay, so when you take, let's assume a sphere reference or earth reference, so in that context what you can say is north pole is the reference for theta. Let's assume this is a sphere. Okay, this is some kind of a sphere, let's assume. Okay, and this point is basically north pole. So this north pole point is reference. Reference means theta is equal to 0 here in case of spherical coordinate system. Okay, and the angle that is being measured now is measured like this. If you see, this is the reference. We know that this is a positive z axis obviously. Okay, so with respect to positive z axis, if I take a random point on earth, on this sphere, if this is a point P, angle made by this OP line segment with respect to positive z axis, look at where I am taking this angle measurement from, always from north pole, and this is basically theta. And distance OP, distance of the point P from origin, corresponds to the value r. Okay. In case of Earth, the reference is always taken as equator. Equator is taken as 0 degrees. But in case of the typical spherical coordinate system, north pole is taken as reference and all angles are measured with respect to always the north pole. Okay. And whenever you take south pole, let's say, so in case of south pole, then how much will be the angle? If I take a point here, okay, on the south pole, so then how much is the value of theta? So angle measured of, if I want south pole, if I want to reach the point south pole, this point P has to move like this, right? So in the process, how much amount of angle you are moving with respect to north pole right now? 180 degrees. So here this corresponds to 180 degrees south pole. And north pole is theta equal to 0, south pole is theta equal to 180. What about equator? Equator in our context can be called as xy plane. Yeah, whatever is equator in general on Earth is nothing but xy plane here. And for xy plane, theta value becomes equal to 90 degrees. Okay. Yes, right. And now, what are the ranges of and phi? Anything with respect to phi remains the same as compared to what we had seen in the case of cylindrical coordinate system. Okay. So here this part remains the same as compared to cylindrical coordinate system. So you are supposed to be careful regarding only 4, you can say, parameters here: theta, phi, r and rho. Okay, theta, phi, r, rho. If you are comfortable with all these 4 quantities, then yeah, point conversion, vector conversion, all these things becomes very easy for you. Okay. Next, let us look at the ranges. If I want to cover every point in universe, the range of r will be from 0 to infinity. So for r, it is nothing but from 0 to infinity. And for theta, just now we have seen, I want to cover every point on Earth. So means north pole to south pole, if I want to cover, the range of theta is from 0 to 180 degrees, or from 0 to simply pi, 0 to pi. Again, examiner will not give you this range information. So that is your duty to remember the range information. Okay. For phi, it remains the same as compared to the previous case, cylindrical coordinate system, which is from 0 to 2 pi. Okay. So you can understand that on Earth, let's assume you take Earth reference. Easy way of remembering spherical coordinate system is, now whenever you are moving along this circle, so are you not moving around z axis? Because this is nothing but z axis. North pole to south pole is nothing but z axis. So if you are moving along this latitude circle, or equator is also another latitude circle, So in that case, you are moving along phi direction. Okay, you are moving along phi direction. Only phi changes. When you are moving from north pole to south pole, let's assume, along this particular longitude, so in that case, basically you are moving along the direction of theta. Okay, so on Earth, there are 2 ways in which you can move along a particular circle. One circle is from north pole to south pole. In fact, that is a semicircle, and there is a full circle here. And if you are moving along this latitude circle, so in that case, you are moving along phi direction. So latitude movement means phi movement, and longitude movement means basically theta movement. Okay. And if you are going towards the center of Earth or away from center of Earth, it means that now you are moving along r direction, r cap direction. Okay. But yeah, the important part here is ranges. Ranges of r, theta, phi, very important for us. Okay. Next, after the ranges, next is nothing but point conversion. So we have total 3 into 2, total 6 point conversions, but out of them, 2 are very important. If you remember these 2, then getting remaining guys is not a big deal for you. Okay. So first is rectangular to cylindrical. Okay. So in this case, to remember this rectangular to cylindrical also very easily, you can remember this particular xy plane. So you have xy plane, and then you are taking, let's assume, a circle on this particular xy plane, maybe this circle, and somewhere on the circle you have the point of interest. Maybe this is the point of interest. This is your point of interest. So, and here on xy plane, the intersection of x-axis and y-axis corresponds to origin, or also z-axis. Okay, you are looking directly from the viewpoint of z-axis. So this is basically origin currently. So how much will be this distance right now? This is nothing but rho. If you remember this diagram, more or less the point conversion from cylindrical to rectangular is complete for you. And how much is this angle? This is nothing but phi. And if you take projections, take projection of this point P, let's assume on x-axis, this x distance corresponds to the variable x, and if you take the projection of this point P on y-axis, then the distance that is measured on y-axis corresponds to y. Now you can clearly see that there is a right angle triangle here, and from that right angle triangle, the first set of point conversion is complete. That is nothing but x becomes equal to, x is adjacent to phi, and hypotenuse for this right angle triangle is nothing but rho. So x is equal to rho times cos phi, because x is nothing but adjacent distance. And similarly, what about y then? Y is nothing but rho times sin phi, because yeah, the y distance is basically opposite to that of phi, so this becomes rho times sin phi. That's it. And what about z? Z in case of cylindrical, rectangular, both are same, so z becomes equal to z. Now once you get this set of expressions, getting the other set now is not a big deal. Okay, from these guys now I can have another set. Okay, so here given rho phi z, you have got x phi z. Reverse, we want given x phi z, we want rho phi z. And from that again triangle only, rho becomes equal to square root of x square plus y square, and phi is equal to, here tan phi is equal to y by x, so phi is equal to tan inverse of y by x, and lastly z becomes equal to z. Okay, so this is a conversion of the points from xyz to rho phi z, second conversion. Okay, next spherical to cylindrical. Again remember one diagram, so you don't even have to mug up this formula now. So that one diagram is nothing but you have z axis, so you are taking basically a part of earth, you can say. Okay, in fact one longitude on earth. So this is the positive z axis, this is origin, and this is some point on xy plane, some point on equator, you can say. So hence I would say this is xy plane. Okay, and whenever you draw longitude, longitude is basically a part of a circle, right? So I'll get the shape like this, I'll get the shape like this, it will be a part of a circle. This is a part of a circle, and on this part of a circle we have the point of interest. So this is basically the point of interest. Okay, and distance between origin as well as the point of interest is r. Angle made by OP line segment with respect to positive z axis corresponds to theta. That's it. If you remember these two diagrams, again the second part of the point conversion is complete. Okay. Yeah. So if you take projections, if you remember, distance of a point from z axis corresponds to how much? That becomes equal to rho. That becomes equal to rho. And furthermore, distance of a point P from xy plane corresponds to how much? This is z. Okay. Do remember this diagram. Then again the second set of conversion, point conversion is complete. So that is nothing but, yeah, you can see in this triangle, again in this diagram you're having a right angle triangle. Adjacent to theta you're having this distance which is z. So z becomes equal to, or will follow the usual order, rho phi z order. So rho becomes equal to, rho if you notice opposite to theta means hypotenuse which is r times sine theta, and then phi in case of cylindrical and spherical both are same, and lastly z is adjacent to theta, so z becomes equal to r times cos theta. Okay, and again the moment you remember this, getting the other set is not a big deal. What is the other set? The other set is nothing but again from this triangle, what is r equal to? R is equal to square root of rho square plus z square, and theta is equal to, from this diagram tan theta is equal to rho divided by adjacent length z. So theta is equal to tan inverse of, this is tan inverse of rho divided by z. Phi in both cases is one and the same. Okay, that's it. If you remember these two by means of these two diagrams, now the last conversion is not a big deal. Okay, the last conversion, if you notice, I want to convert, I'm sorry, this is from spherical to rectangular. Okay, this is spherical to rectangular. So if you notice here, x is equal to rho cos phi, but rho itself is how much? R sin theta. So when you combine both of them, now I can write x to be equal to here. Originally it was rho cos phi, but rho is r sin theta. So this becomes equal to r sin theta cos phi. So this is not a new formula right now. By combining both of those yellow guys, we have got this one, which is nothing but x is equal to r sin theta cos phi. Similarly, what is y? Y is equal to rho sin phi, but rho is r sin theta, and hence this is r sin theta sin phi. Don't mug this up, not required. Okay. And lastly, what about z? Z in terms of only r theta phi, as you can see here, is nothing but r cos theta. That's it. Given r theta phi, now I got the expressions in terms of x, y, z. Lastly, the reverse, which is nothing but how to get r theta phi from basically x, y, z. Here r is equal to rho square plus z square, but rho square itself is equal to x square plus y square. Combining both, we have r being equal to square root of x square plus y square plus z square, and theta is equal to tan inverse of square root of tan inverse of rho by z. Rho is equal to again square root of x square plus y square divided by z. Phi, yeah, phi in both cases is same. Phi in cylindrical and spherical is same, and that phi is equal to tan inverse of y by x. So this is basically tan inverse of y by x. Now here, if you notice, given x, y, z, we can find out r theta phi. So total we have 6 conversions here. But if you notice here, the main points here are these two diagrams. If you remember these two diagrams, getting these and these terms is not a big deal, and from them you can get the remaining terms. Okay. So this is regarding point conversion briefly. Next is we have vector conversion. So in vector conversion, what are we trying to do is nothing but we have a field vector, and that field vector is a bar, let's assume. A bar could be expressed in terms of both cylindrical, spherical as well as rectangular. In rectangular coordinate system, we are writing it as ax times x cap plus ay times y cap plus az times z cap. So ax, ay, az are x, y, z components of a bar, and this is a representation of this field in terms of rectangular coordinate system. So this is in terms of rectangular coordinate system. Next, can we express the same thing in cylindrical also? Yes. So in that case, we have a rho times rho cap, a phi cap plus az z cap. Okay. And can we express it also in terms of spherical coordinate system? Yes. Which is ar r cap, a theta cap plus a phi cap. So in all the three cases, the vector field remains same, but only thing is the representation of that vector field changes. So this is in case of cylindrical coordinate system, and the last one is in terms of the spherical coordinate system. Okay. So given this, we should be able to convert this vector field from one coordinate system to another coordinate system. Okay. So here I would give you some transformation matrices. So the first transformation matrix, let me call it as nothing but A, some random 3×3 matrix this is. So we have cos phi, sin phi, 0, and minus sin phi, cos phi, 0, lastly 0, 0, 1. Okay. This is one transformation matrix, and by using this transformation matrix now, we can convert the vector field from one coordinate system to another, that is initially from cylindrical to rectangular and also vice versa. Okay. So that is a rho, the component here a rho, a phi and az. How do you write this in terms of a, x, y and z? That is nothing but the matrix you have taken here, this 3×3 matrix, multiplied with the components of ax, ay as well as az. Now if you want the reverse, that is if you want ax, ay, az in terms of, let's assume a rho, a phi, az, you are supposed to take here a inverse. But here in all these transformation matrices, whenever you take inverse, that is as good as saying that you are taking a transpose. Okay, the inverse becomes equal to transpose only. So the other one is ax, ay, az. See, this logic is applicable only in case of the vector conversions, not in general in matrices. Okay. So this is the transpose of the matrix we have taken multiplied with a rho, a phi and az. Okay. Yeah. So this is regarding the conversion of the vector component from one form to another form. Next spherical to cylindrical. Again, the moment you remember this portion, the last portion is derived from the first and second results only. Okay. So here the matrix that you will take will be, there is another matrix now we are taking, the transformation matrix B, which is equal to sin theta 0 cos theta and then cos theta 0 minus sin theta 0 1 0. Okay. This is another transformation matrix and this is written in terms of theta. The previous one was in terms of phi, obviously the parameter that you have in case of cylindrical, and the present one is in terms of theta. Okay. Now here let's assume I want AR, A theta, A phi. The spherical components, if I want the spherical components, then I will simply multiply, this becomes equal to the 3 by 3 matrix that you have taken here B times the vector components in cylindrical coordinate system, which is a rho, a phi and az. Okay. And like in the previous case, if you want the reverse from this, if you want the reverse, that is if you want a rho phi z in terms of AR theta phi, all you have to do is nothing but take transpose of this. Technically you are supposed to take inverse, but here the inversion becomes equivalent to the transpose only in this case. So a rho, a theta, a phi, sorry, a rho, a phi, a rho, a phi as well as az. Okay. Now this becomes equal to the same 3 by 3 matrix transpose multiplied with AR, A theta, A phi. Okay, that's it. And if you now again notice here AR is equal to some B matrix into A rho, A phi, Az. But what is A rho, A phi, Az? A rho, A phi, Az is nothing but matrix A into Ax, Y, Z. Okay, so means can I multiply or can I replace A rho, A phi, Az by means of this entire RHS portion here? Yes. And if I do that, I'm not writing them in the form of expressions though, but I'm just giving you the final answer. The answer is nothing but now, if I want here AR, A theta, A phi, the vector components of AR, A theta, A phi, they look a bit complex, so not easy to mug up also, so don't mug up. Okay, remember it like this. There is a matrix B here, so let's take matrix B. And in place of A rho, A phi, Az, we are replacing it with A into Ax, Ay, Az column matrix. Okay, so means A, the 3 by 3 matrix A into Ax, Ay, Az. So both of them are nothing but 3 by 3 matrices. Multiplication of two 3 by 3 matrices will give you another 3 by 3 matrix, and let me call it as nothing but C. So C is another 3 by 3 matrix. And accordingly, if you want the reverse, okay, if you want the reverse conversion, that is if you want Ax, Ay, Az, okay, so this would become equal to the matrix C transpose times AR, A theta, A phi. Very rarely you will be using this formula in case of GATE exam or other exams also, because these kind of questions, they are not easy. They will take definitely a lot of time. So due to which you don't see these questions mainly in GATE exam. Okay. Yeah. Yeah. Just to answer, transmission lines will be the topic for day after tomorrow. Tomorrow will be core statics portion. Okay. And yeah, I'll share these slides with you. Don't worry. I'll discuss about that. Anti-clockwise, clockwise. What is the directions? We will come to that. While doing some problems, right? Because anti-clockwise, clockwise depends on the viewpoint that you are looking at, whether you are seeing from North Pole or South Pole. From North Pole, anti-clockwise direction will be equivalent to from south pole clockwise direction. So anti-clockwise, clockwise should also have a reference point. So what is the reference point also we'll see. Okay, don't worry. So this is regarding the point as well as vector conversion revision. Next, differential parameters in terms of curvilinear coordinate system. Very important. See, the main purpose of discussing all these points in coordinate systems is mainly to ultimately use them in case of either integration or differentiation. Okay, and integrations also we will be using differential parameters, whether it is line integration problems, Stokes theorem problem, or in case of, let's say, divergence theorem problem, we will be using volume as well as surface integrations, etc. So we have to know the differential parameters. Initially, we look at the differential parameters in case of curvilinear coordinate system. Curvilinear coordinate system is a generalized coordinate system, and who are the variables here? I am assuming that the variables here are nothing but u, v, w. Okay, so these are the variables. So then what is the differential length? So first is nothing but differential length given by dl bar. In curvilinear coordinate system, this is given by h1, which is a constant or a scale factor, times du. Du is a change of the first variable u along u cap direction, along the direction of u. So the differential length is nothing but h1 times du, and along v direction the length is h2 times dv, v cap, and along w direction it is h3 times dw, w cap. Okay. Now, second is differential area. That's it. If you are able to write differential length properly, differential area, differential volume is not a big deal. See, this is my notation. Okay, this is my notation of ds bar. I'll also show it to you from exam point of view also. Sometimes you also see it as nothing but dA bar. Okay, and sometimes you also see the same ds bar given to you as nothing but some ds times n cap. All are basically one and the same. My notation is ds bar. That same ds bar is also equal to dA bar, or that same thing is also same as ds times n cap and so on. This is my notation though. Okay, and yeah, this ds bar becomes equal to, if I want area along u direction, then what? And if I want area along v direction, then what? W direction, then what? If I want area along u cap direction, I have to multiply the other two lengths, that is v and w length. If you multiply them, we get h2, h3 times dv, dw. Okay, and if I want v area along v cap direction, then I'm supposed to multiply the u as well as w length, which is in this case h1, h3. This is h1, h3 times du, dw. And lastly, if I want area along w direction, I have to multiply the first two lengths, which is basically h1, h2 times du, dv. Okay, so yeah, this is what is the differential area in curvilinear coordinate system. Lastly, the differential volume. Okay, next we have the differential volume. Differential length and area are vector quantities. Differential volume is a scalar quantity. So this is dv. So this dv becomes equal to multiplication of all the three lengths. If you multiply all the three lengths, then we'll get h1, h2, h3 du, dv, dw. Okay, so amongst differential length, area and volume, what is the most important one? Yeah, the first one. If you are able to remember the differential length, then getting the area and volume is not at all a big deal. So that is the main purpose of even writing this, just to show you as to how to get differential area and volume by using differential length. So if you are remembering the differential parameters in case of all the three coordinate systems, you have to put a lot of effort in terms of only differential length, not for differential area and volume. They can be derived from differential length only. Okay, so let us now see what are the differential parameters in case of all the coordinate systems, starting with rectangular coordinate system. In rectangular coordinate system, differential length dl bar is given by, see, not just here, wherever we have a parameter as nothing but length parameter. Here in case of rectangular coordinate system, okay, who are length parameters? All three guys. X, Y, Z terms are nothing but length parameters. In case of cylindrical coordinate system, okay, what are the parameters we are having? Rho, phi, z. Phi is angle, rho is a distance, means some distance parameter, and phi z is also basically distance parameter. So I'm having two distance parameters, one angle here. So here rho as well as z both are nothing but distance parameters, whereas phi that you see here, phi is basically angle parameter. Okay, whereas in the previous case all three are distances. All three are basically distances. Okay. And next, in case of spherical coordinate system, what are the variables? The variables are r, theta as well as phi. So here only r is nothing but a distance parameter, whereas theta and phi basically are angles. Okay. So why are we discussing this? Because if you want to write dl bar in all these three cases, yeah, we will have dr times r cap. Differential parameter is always there, d theta times theta cap plus d phi times phi cap. This differential parameter will always be there. Here also, if I write dl bar, d rho times rho cap plus d phi times phi cap plus dz times z cap. Dz times z cap. Okay. And similarly, in rectangular coordinate system, we'll have dx times x cap, dy times y cap plus dz times z cap. So total we have to remember 9 terms, 1, 2, 3, here cylindrical, spherical, total 9 terms. Okay. So wherever you have distance parameter, so in that case the coefficient of the differential parameter is always 1. So here 1 dx, 1 dy, 1 dz, which is nothing but dx dy dz only. In case of cylindrical, yeah, the coefficient of d rho, because rho and z are distances, coefficient of d rho is 1, coefficient of dz is also 1, but not the coefficient of angle. The coefficient of angles will be some other variable or some other combination of variables or some other function you can say, and that term here is nothing but rho. Okay, the coefficient that you are having for d phi now becomes equal to rho. Only for angle parameters we'll have coefficients, and how many coefficients we'll have overall, we will notice that there are only 2. Okay. Next, in case of spherical, r is nothing but distance parameter and hence coefficient is 1. And coefficient of d theta is r. Okay. Coefficient of d phi same as cylindrical. What is the coefficient of d phi in case of cylindrical? It is nothing but rho. And how do you express rho in terms of r and theta? So in terms of r and theta, we express rho as r sine theta. So that is what we are using. So there also remember it as nothing but rho only. So there also it is nothing but rho, but written in terms of r and theta, which is r sine theta. So the coefficient of d phi is rho. The coefficient of d theta is nothing but r. That's it. If you remember this, differential length, area and volume topic is complete for you. Now the moment you get this, now can you write the expression for ds bar for all the 3 coordinate systems? Yes. ds bar, if I want r cap area, what is r cap area right now? Multiply other 2 lengths. Okay. Logic remains same here also. If I want, let's assume theta cap area, other than theta cap, multiply the lengths that you are having in r as well as phi directions. And if you want phi cap area, okay, so then again multiply the lengths which are along other 2 directions other than phi cap. Yeah, first of all, r cap. Along r cap, what is the area you're having? So r into r square sine theta d theta d phi. D theta d phi. And what about theta cap? This is r sine theta times dr d phi. So this is r sine theta dr d phi. And lastly, if I want phi area, multiply r and theta length, which is nothing but r dr d theta. This is r dr d theta. And finally, what is differential volume in case of spherical coordinate system? Multiply all the 3 guys. If you do that, we'll get r square, and then you have sine theta, and then the differential parameters of dr, d theta, and d phi. Dr, d theta, d phi. That's it. Same logic in the cylindrical also. What is ds bar here? ds bar, it will have an area along rho cap direction, it will have an area along phi cap direction, also some area along z cap direction. Okay. Yeah. So along rho cap direction, what is the area? Rho d phi dz. So this is rho d phi dz. Along phi cap direction, d rho dz. D rho dz. Along z cap direction, this is z cap term is very important because a lot many questions that will be given to you will be given on xy plane, and perpendicular to xy plane direction is nothing but z cap. So z cap area is important. Okay. So which is rho d phi. So this is rho d phi. Okay. And what about the differential volume? Differential volume is equal to multiply all the three lengths, which is rho d phi and dz. Okay. And in rectangular coordinate system, what is ds bar? If I want x area, multiply y and z length, dy dz x cap, plus if I want, let's assume y area, multiply x and z length, and if I want z area, multiply x and y length. Okay. And then differential volume, pretty simple, dx dy dz. So this is the starting point of most of the vector calculus questions. Without this differential parameters, you can't move forward. One more thing that is required for you to solve the problem is ranges, and hence we have discussed mainly the ranges as well as also the differential parameters. Once in a while, probably you are supposed to use vector conversion also or point conversion also. Okay. So for that reason, we have discussed even the vector conversion, point conversion principles also. Okay. Amongst all the three that we have discussed, the most important one, the most repeatedly used one in exams will be the Z area. So this one. Okay. So this is the most importantly or most important differential parameter. So differential area in usually Z direction. So you have two such areas. Along Z direction, we have dx dy z cap. Also we have in polar coordinate system or cylindrical coordinate system rho d phi z cap. Okay. So this is something that you have to remember. So ds bar along z cap direction. If I am only separating this guy, I am taking ds bar only along z cap direction, that becomes equal to, this is dx dy z cap, or also equal to rho d phi z cap. So wherever we see dx dy, can I replace that with rho d phi? Yes. If it is required, we can definitely convert, or we can definitely write dx dy in terms of rho d phi. This is what examiners are doing in the current times. They are giving you half of the data in cylindrical coordinate system, the other half of the data in rectangular coordinate system. So ultimately you have to do vector conversion, or you are supposed to convert your data from that is rectangular to cylindrical or cylindrical to rectangular. Conversion is what you are supposed to do. Okay. And mostly what students do is always they take rectangular coordinate system. But probably for that particular problem, it is very easy if you convert everything in terms of cylindrical coordinate system. So don't be reluctant in doing the problem in terms of cylindrical coordinate system. People have this reluctance. They always go for only rectangular. But that is what is the intention of examiner. Examiner wants you to solve the problem by means of cylindrical, and if you choose cylindrical there, problem may become very simple for you. Okay. Yeah. So let's go for the next one. We have a few problems right now, and finally scale factors table. Okay. So by comparing differential length in all the three cases, differential length in case of rectangular, curvilinear, first of all curvilinear, and then rectangular, cylindrical, and spherical. Now we can form this table. So first you are having here curvilinear coordinate system. In curvilinear coordinate system, who are the variables? Variables are u, v as well as w, and the corresponding scale factors. Scale factor for u is h1, that is coefficient of du is nothing but h1, coefficient of dv is nothing but h2, coefficient of dw is h3. Okay. So this is h2 and this is h3. Corresponding variables in case of rectangular coordinate system. In rectangular coordinate system, instead of u, v, w, we are having x, y, z in that same order. Next, in case of cylindrical coordinate system, so we have rho, phi, and z. And lastly, in case of spherical coordinate system, we have r, theta, as well as phi, right? And scale factors, wherever you see distance parameters, x, y, z distances, means scale factor is equal to 1. And next, rho, z are distances, scale factor is equal to 1. And r is also distance, scale factor is equal to 1. Then the remaining terms are 2 phi terms you are having. For phi, the scale factor is rho in cylindrical coordinate system. And here also, for phi, what is the scale factor? Rho, but rho written in terms of r and theta, because lastly you are having spherical. Rho written in terms of r and theta is nothing but r sine theta. And finally, the scale factor for theta is r. That's it. So this is the table of scale factors. Do remember it. It will make your problem solving or remembering of formulae in the next topic, vector calculus, becomes very easy. So these are the broad topics you are having in coordinate geometry. So this is coordinate geometry in brief for you. Let us look at a few problems right now on this topic. Do by heart these two vector fields. We generally get 100% one question either in electrical or EC paper, pakka one question from either of these two vector fields. Okay. So this is a very commonly used vector field to explain the radial field concept, and this is one of the commonly used vector field to explain the circulating field concept. Okay. So I want these two fields to be converted into basically polar coordinate system. So let us apply the principles. In fact, you can try out with me. If you remember the answer, you can post the answer in the comment box here, right? Yeah, this is position vector in xy plane. Okay, only in case of xy plane. But yeah, if you remember the answer, I want the answer in terms of polar coordinate system. Try to get the answer. If you remember it, well and good. Else you can try out with me, parallelly with me. What is this x? X is nothing but ax. Coefficient of x cap is ax now. Coefficient of y cap is ay in the first problem. In the second problem, coefficient of ax is nothing but minus y ax. Coefficient of y cap is x, which is nothing but ay. So here, what is a rho? First, we will get a rho. A rho from the matrix that we have taken earlier, no? From one of the matrix we have taken earlier. This matrix. What is a rho equal to? This matrix multiplied with ax, ay, az components. So means cos phi into ax, sin phi into ay, lastly 0. So we will take that only. Okay. So this is cos phi times ax plus sin phi times ay. Okay. And substitute the values of ax and ay. In the given data, ax is equal to x and ay is equal to y. And upon substitution, we get the values as what? So this becomes equal to x cos phi plus y sin phi. Now in polar coordinate system, everything should be in terms of rho phi z. What is x right now? What is x here? X, now point conversion. X is rho cos phi and y is rho sin phi. Okay. And hence, if you substitute this data, what do we get? So we get rho, I can take common. In the first and second parts, you can take rho common. Then you have cos square phi plus sin square phi. So this is ultimately rho cos square phi plus sin square phi becomes equal to simply rho. Yeah, cos square phi plus sin square phi becomes 1. And hence a rho component is nothing but rho only. What about a phi component accordingly? A phi component is equal to, so this is according to the formula that we have. If you go for the matrix that we have discussed earlier, this one. What is second guy? A rho. A rho is equal to second row sin phi ax minus sin phi ax plus cos phi ay. So accordingly, I can write the expression here as this is minus sin phi times ax plus cos phi. I'm sorry. A phi is equal to minus sin phi times ax plus cos phi times ay. Substitute the values. The values will be same as the previous case. Ax is equal to x from the given data. Ay is equal to y, and upon substitution we get the answer as this is minus x times sine phi. This is minus x times sine phi plus y times cos phi. Again, like in the previous case, you can substitute x to be equal to rho cos phi, y is equal to rho sin phi. So then finally we get the answer as this becomes equal to, again I can take rho common in both cases. We have minus sin phi cos phi, sin phi cos phi. So yeah, overall 0. So means there is no a phi component, and anyway there is no az component, no. Az component is also equal to az component, nothing is there. So finally we have got this guy. Do remember the final answer, guys. You'll understand the importance of this only if you look at the previous questions a lot. So wherever you see x cap plus y cap from now on, without wasting time in exam, you can write the answer as nothing but this is simply rho times rho cap. Okay, rho times rho cap, because only the rho cap coefficient is nothing but non-zero. The phi cap as well as z cap terms both are nothing but 0. So technically I should be writing it as rho cap plus 0 phi cap plus 0 z cap is what I'm supposed to write here. Okay, which is ultimately what? Rho times rho cap. And what is rho cap direction? Like I've told you the other, in the other slide. So rho cap corresponds to radial direction. What kind of radial direction? It is radially away from z axis. Radially away from z axis. So means this field is basically a radial field, you can see. Okay, which is the first one. Second one is minus y x cap plus x y cap. Procedure remains same like in the previous case. Coefficient of x cap. The coefficient of x cap is known as ax. The coefficient of y cap is known as ay. Okay, and first I want a rho component. What is a rho? This is cos phi times ax plus sin phi times ay. In the present case, what is ax and ay? Ax becomes equal to minus y, ay becomes equal to coefficient of y cap is ay x. And similarly, what is a phi? A phi as per the formula is minus sin phi times ax plus cos phi times ay. Obviously, now also ax, ay components remain same. So these components pakka remain same. And when you substitute them, the expressions you get for the first and second terms are what? So this is minus y cos phi plus x times sin phi. And a phi is equal to minus of minus is plus, we have y times sin phi, y sin phi plus x cos phi. Okay. And what is the value of y and x here again? Point conversion. So y means rho times sin phi, and again x means here rho times cos phi. Okay. Yeah, substitute the data, what do we get? Minus rho sin phi cos phi. Rho sin phi cos phi means the first term, a rho term becomes 0. What about a phi term? A phi term is rho sin square phi plus rho cos square phi becomes equal to rho sin square plus cos square phi becomes equal to rho. So now what happened is nothing but only a phi term remained, the remaining terms are 0. So az becomes equal to 0. Even in 2024 EC paper, we have got this field. Instead of y x cap plus x y cap, minus y x cap plus x y cap, we have got the data as nothing but y x cap minus x y cap. So minus of this vector field is what is given to us. And what about this vector field now? This vector field finally minus y x cap. Wherever you see from now on minus y x cap plus x y cap, so you can replace it with rho times phi cap, because only a phi term became non-zero term, remaining guys are zeros. Okay, and what is the coefficient there? What is the a phi value? A phi value, which is the coefficient of phi cap, is nothing but rho, and hence we are writing it as nothing but rho times phi cap. Now what is this phi direction? I have told you the I'm sorry. Yeah. So what is this phi cap direction I've told you? Phi cap is nothing but this is the direction which is circulating around z axis. Yeah, like someone earlier was asking me, sir, is it clockwise circulation or anti-clockwise circulation? Direction is nothing but when seen on xy plane, the standard xy plane. So this is nothing but anti-clockwise circulation. So this is anti-clockwise circulation. When seen where? When seen on xy plane. Okay, not in every viewpoint, but rather when seen on the typical xy plane. So in that case, it is nothing but anti-clockwise circulation. Okay. Yeah, so this is regarding the two very important fields. Guys, if you remember these standard forms, you can save this time, whatever time we have spent here, nearly 1.5 minute of time, you can save this in examination hall. Whenever you see x cap plus y cap, replace that with rho cap, previous problem rho cap. Okay, and wherever you see minus y x cap plus xy cap, that is equivalent to what? That is equivalent to the present one, which is nothing but rho phi cap. Phi cap means circulating direction, rho cap means radially away from z axis direction. Okay. Yeah. Yes. Next, let's look at some of the previous questions in GATE on the basis of only coordinate geometry, not vector calculus, not anything else, only on the basis of, let's assume, coordinate geometry. Okay, so this is one question, EC paper 2016. I think it was a 2-mark question, that too. Okay, so the region is specified. You have been given some limits for rho. These are the limits for rho given to you, and these are the limits for phi. Okay, and also the limits for z given to you, and has a volume of the region specified by so and so limits has how much amount of volume. So if I want total volume, what is the formula? Volume is equal to, can I say, integration of dV? Yes. Now, what dV you are supposed to take? dV in case of cylindrical coordinate system. In cylindrical coordinate system, what is dV? This is nothing but rho d rho d phi dz. Yeah, to solve this question, the critical step is nothing but this. If you remember this portion, problem is complete. If you forgot this, yeah, entire problem is of no use. Even though you have limits, you know how to perform integrations, but still that is entirely of no use if you don't remember this particular dV in cylindrical coordinate system has nothing but rho d rho d phi dz, because entire data was given in terms of only cylindrical coordinate system. Okay. Yeah, so this becomes equal to how much? This is nothing but rho square divided by 2. Okay, and then integration of rho d rho is nothing but rho square by 2. Integration of 1 d phi is simply phi, and integration of dz is nothing but z. Okay, and limits for rho. What are the limits for rho now? Rho limits are from 3 to 5, and phi limits are from where to where? Pi by 8 to pi by 4. Okay, z limits are from where to where? 3 to 4.5. If you substitute the limits and do the calculation, yeah, what is the value you get? 5 square is 25 minus 3 square is 9. 25 minus 9 is 16. 16 by 2 is 8. So this is 8 into pi by 4 minus pi by 8 is pi into 1 by 4 minus 1 by 8 is pi by 8. So the second limits after the substitution is nothing but pi by 8. The last one is 4.5 minus 3 is 1.5. So this is 1.5. Okay. So finally, if you cancel out 8s here, both 8s are gone, and then the final answer is what now? The final answer is 1.5 times pi, or which is also equal to 3 pi by 2. Okay. Yeah, you can do the calculation and get the numerical value here. You are supposed to express the answer up to 2 decimals, I believe, in this question. Okay, a simple question, but only thing is you have to know the expression of dV properly here. Okay, limits anywhere given to you in the exam. So limits, if you don't remember, chalega for you, but rather you have to remember the expression of dV here. Okay, a similar kind of a question we have got in fact, even this year 2024 also. So this is a EC question 2024 2-mark question. Okay, yeah, look at this question now, try to answer this. Consider the earth to be a perfect sphere of radius r. So let me take so I am assuming earth to be a perfect sphere. Okay, so let's assume the center line that you have taken is nothing but this is equator, and on the topmost point we have north pole, bottommost point we have south pole, right? Yes. Now consider the area to be a perfect sphere of radius r. So the radius value is r here, radius of this earth is r. Then the surface area of the region enclosed by 60 degrees north. So I have to draw this line first. 60 degrees north line I'm supposed to draw. So 60 degrees north. So when they say 60 degrees north, they are giving the data with respect to what? With respect to the typical equator reference. Okay. So this 60 degrees north is obviously with respect to equator reference. Okay. So means, yeah, you have this equator. So equator is considered as what? 0 degrees, right? So then you have this latitude known as now, this latitude is known as now 60 degrees north. This is known as 60 degrees north. Now there is one area that is enclosed, and that area is enclosing or contains the north pole. So basically this area, if you notice, this area. So you are supposed to identify that particular area where, yeah, enclosed within this particular circle, also including the north pole. What is the amount of area? Okay, so that is what you are supposed to find out. Here, two things are very important. First is nothing but you have to know what are the limits for theta properly. You have to remember the range for phi also, complete 360 degree range for phi. And also you have to know the differential parameter of differential surface area when r is constant. Okay. So now what is the procedure in which we can solve this problem? Let's look at step by step here. So I want the total surface area. I want the total surface area. And the total surface area obviously is nothing but, so this becomes equal to integration of ds. Now what is the ds we'll take? We'll take that ds where r is constant. When r is constant, so in case of spherical coordinate system, yeah, what is the surface area along r cap direction, radially away from the surface of the earth. Now what is the surface area we have? That is nothing but r square sine theta d theta d phi. Okay, so which is what you're supposed to take. Why? Because when I draw this diagram, when I draw this diagram, what is the radial direction? If I ask you what is the radial direction for this surface, radial direction is nothing but away from origin only. So away from origin means what? R cap direction. And I am taking area only along r cap direction. Along r cap direction, what is the differential area? Just now we have seen this becomes equal to integration of r square sine theta d theta d phi. Now this is an integration with respect to what variables? Here the integration is only with respect to theta and phi variables, right? Means r is constant. What is the constant value of r? The constant value of r is nothing but capital R given. So this is r square, and I can take it out. I can take it out. Now if you look at the problem, it's very simple. All you have to do is integration with respect to theta and phi. Okay, yeah. So this becomes equal to, I am keeping r square outside. Now integration of sine theta becomes how much? Cos theta. And integration of 1 d phi becomes how much? Phi. Again, very critical. Write the proper values for theta and phi here. Okay, proper limits for theta and phi. See, am I covering the entire 360 degrees here? If I'm moving along the latitude, am I moving the entire 360 degrees? Yes. So means here the range for phi is from 0 to 2 pi. Nowhere in the question you have this information. Okay, but that is implied. That is the reason why ranges of coordinate variables are very important. Next, what is the limits for theta? What is the limit for theta? Anyone? I want this answer from you. Tell me what is the limit for theta? minus V 0 to 60, no. See here, when I measure the angle, how do I measure the angle? Please look at. My interest is in what area? That is something you have to notice. Okay, what is my area of interest? You have to notice that properly. 0 to 60 means you are going from where to where? Here to somewhere here. Okay, whatever 60 degrees north I have given you, that is the angle measured with respect to what reference? Equator reference. So here, who is 60 degrees? So this angle corresponds to 60 degrees. Okay, this angle corresponds to 60 degrees. Unfortunately, that will be one of the options for you. Whatever 0 to 60 limits you have taken. Yes, good. Pavani and Vamshi, good. The limits are from 0 to 30. Okay, because you are taking the reference as what I want to cover this area. I'm not starting from here, I'm starting from here. Okay, so means here, since this is my starting point, at my starting point, what is the value of theta? Yeah, now I'm writing in terms of theta. I'm sorry. What is the value of theta? Yeah, here the value of theta becomes equal to 0 degrees. So this is the starting point for you, and you're moving like this. Okay, you're moving like this, and finally when you reach here, how much is the total angle that you have covered? Since the reference is from north pole right now, okay, that same 60 degrees north with respect to equator is also equal to 30 degrees with respect to the north pole reference. Okay, both are the same thing. So here this angle now corresponds to how much? This corresponds to 30 degrees. Okay, so the 60 degrees with respect to equator is also same as 30 degrees with respect to north pole, and our goal is to cover only this area. So since we are covering only this area, yeah, the theta limits, because in spherical coordinate system theta is always measured from where? Measured from north pole. Okay, means this is a starting point, and at the starting point the range of the value of theta is nothing but 0, and at the ending point here, what is the value of theta now? 30 degrees. So the limits for theta will be from 0 to 30 degrees. Okay, and substitute these values now. If you substitute these values, what will you get? So minus cos 30. Cos 30 is root 3 by 2, and minus of minus is plus. Cos 0 is nothing but 1. So this is r square into minus root 3 by 2. This is minus root 3 by 2 plus 1 into 2 pi. Okay, and overall when you multiply, I believe the answer becomes equal to pi r square into, when you take LCM, you will get 2 minus root 3, 2 minus root 3. Okay, denominator 2 and 2 is gone. So finally this is the answer. If you look at the options, I think, yeah, D is the correct answer. It was a 2-mark question, and this question can't be solved without knowing basically the differential surface area, limits for phi, and also understanding how you are measuring theta. If you don't understand properly how you measure theta in case of spherical coordinate system, now, yeah, solving this question is not a big deal. But if you know all these things, no, hardly this question will take some maybe a minute or 1.5 minute of time, not more than that. A simple problem this is. Only thing is these 3 things. Okay, ds, understanding ds in spherical coordinate system, limits for phi, limits for theta, and how you calculate theta. All these 3 things are very important for you. Okay, so I hope this question is clear, right? Okay, so what if we took 60 to 90? Again, see, Kranti, 60 to 90 if you are taking means you are covering this region. Please understand this strip. Maybe this is, with respect to this is 60. I'll take a different diagram though to make you understand what will happen if you take 60 to 90. First of all, you will get wrong answer, at least in this problem. Why? The question is about why. Why will you get a wrong answer? Yeah. Again, Earth, North Pole, equator. Okay, and this is the center point, let's assume. This is another yeah. Okay, So like this, I have taken 3 circles, 3 latitudes in fact. This latitude is known as equator. This latitude is known as, first one is equator. This is equator. And let's assume this is 30 degrees north. And this is basically 60 degrees north. Okay. Look at this, the equator is nothing but how much? 0 degrees. Neither north nor south, obviously 0 degrees, right? This is with respect to earth reference. These yellow guys are with respect to earth reference. If you talk about the same things with respect to our spherical coordinate system reference. Now in spherical coordinate system reference, angle always starts from here. This is 0 degrees. And if I say, boss, you are having this 30 degrees. Yes, this is 30 degrees, I agree. With respect to what equator? So this is 30 degrees. And what is 60 degrees then? This would be 60 degrees then. The other angle is nothing but 60 degrees. So means the same 30 degrees north becomes equal to 60 degrees with respect to theta. So in terms of theta, that is nothing but, in terms of spherical coordinate system, the same guy will be called as theta equal to 60. Okay. So this would be called as theta is equal to 60 degrees. Because you are measuring the distance from where now? Angle from where? Angle from North Pole. If I want to reach here from North Pole, how much amount of angle I'm supposed to rotate? I'm supposed to rotate this entire angle, which is nothing but 60 degrees. Okay. And this is 60 north, means how much with respect to spherical coordinate system? Yeah, this 60 north is also equal to, theta is equal to 30 degrees. Because I'm starting from here, and how much angle I'm supposed to rotate so as to reach this particular latitude? It is nothing but North Pole. I'm not moving from equator. You have to keep in mind that one small point. I'm moving from North Pole when it comes to spherical coordinate system. On Earth, we have north and south separately. In case of our spherical coordinate system, there is nothing called as north and south. There is only with respect to North Pole. Okay. And same with equator, like I've told also equator. What is equator known as? Theta is equal to 90 degrees. Because starting from here, how much angle I'm supposed to rotate so as to reach the equator point now? This entire angle, which is nothing but 90 degrees. Okay. So with respect to the spherical coordinate system, North Pole means 0. 60 degrees north with equator reference is theta equal to 30. 30 degrees north corresponds to theta equal to 60. And like someone asked me, sir, what will happen whenever, yeah, I'm taking limits as 60 to 90. Yeah, you have taken the limits from 60 to 90. So you are finding out this area. Okay. You are finding out a strip between maybe 0 degrees, that is equator, and 30 degrees north area. Okay. So this is the area you are finding out, not the area that I require. Okay. We want to find out this area. If you take the limits as nothing but 60 to 90, then you will get this area. You will get some answer, but rather that is the wrong answer. Okay. I hope that part is clear. Yeah. Okay. So this is regarding the coordinate system. Don't neglect this coordinate system. This is one topic people generally neglect. Okay. Assuming that they will convert everything into rectangular coordinate system. This is one mistake people do, that there is one movie actually in Telugu. Okay, that person knows only one dialogue. Okay, that is nothing but idhar aiye. One dialogue in Hindi. That dialogue was idhar aiye. Okay, so if at all he wants to send a person, please go there. He'll go that side and say ki idhar aiye. And this is one logic people do. People are comfortable with rectangular coordinate system, and they will think that, array, I will convert everything into rectangular coordinate system and do the problem in rectangular coordinate system. That will not greatly help you. Okay. So that is how questions are framed also. And only by knowing rectangular coordinate system, at least in the recent times in GATE papers, you will not be able to solve a lot of problems. At least when the intention of examiner is to test your knowledge in terms of spherical and cylindrical coordinate system, which is what we are getting every year. Okay. Yeah. So let's proceed further. So in vector calculus, we mainly have gradient, divergence, curl, and a few double differential operators. The first is nothing but gradient. So what does gradient measure? Gradient basically measures the maximum space rate of change of a function. Okay, so it measures what? Maximum space rate of change of a function. How much a function changes maximum for every 1 meter that you travel in space. Okay, so that is basically gradient. And do remember the formula in curvilinear coordinates, because the moment you remember this, by remembering simply the scale factors, getting the answer in other coordinate systems is not a big deal. Okay. Yeah. For example, if I want the expression in rectangular coordinate system, u, v, w replaced with x, y, z, and h1, h2, h3 in spherical in rectangular coordinate system are 1s. So 1 by 1 is 1, 1 by 1 is 1, 1 by 1 is 1. So simply we have dou f by dou x x cap, dou f by dou y y cap, dou f by dou z z cap. In cylindrical coordinate system, we have variables u, v, w. By the way, this is v, small mistake here. So this should be not u, this should be v. Okay. So yeah, we have u, v, w replaced with rho, phi and z. Okay, that's what we have taken. And then if you notice, the 1 by h1 is 1 by 1. The scale factors in cylindrical are 1 rho 1. h1, h2, h3 are 1 rho 1. So 1 by 1 is 1. 1 by h2 is 1 by rho. That's what we have taken here. So this is one term. Don't miss that. People do miss that. And this is one of the silly mistakes people do. 1 by h3, simply 1 by 1 is nothing but 1 only. Okay. Or one more mistake people do is nothing but either they completely remove it or they write it as rho into dou f by dou phi. No, you should not take it as rho into dou f by dou phi. This is simply 1 by rho into dou f by dou phi from the curvilinear format. Okay. And the last one, in spherical coordinate system, the scale factors are 1 r sin theta. There is rho given here wrongly. This should be r. Okay. So here it should be r. So same terms you are having. 1 by 1 is 1. 1 by h2 is 1 by r. And the last one is 1 by r sin theta. Okay. So these are the components you are having in spherical coordinate system. Very important. Every year we are having at least one question indirectly or directly on gradient. Okay, gradient topic. Let us look at the application of gradient. What kind of questions you will get on gradient? Direct gradient problems very rarely we get. Okay, in the exam you won't see the word gradient also, but still you have to solve that question by using the concept of gradient only. How? We will see that now. Yeah. The first is unit normal. See, this is something that I'm expecting this year at least. Direction of maximum ascent, and then direction of lastly maximum descent. Okay, maximum descent. Ascent means what? Increase. Descent means decrease. Basically, ascent means increase. So instead of ascent, sometimes you see it as nothing but direction of maximum increase. Or lastly, you will see it as nothing but descent. Descent means decrease. Okay, direction of maximum decrease. Because this question can be framed as MSQ. Okay, so you have to be cautious while answering these questions right now. So the logic for all these cases is nothing but direction of gradient. Okay, so direction of gradient. The direction of gradient is simply given by n cap is equal to gradient of the function del bar f divided by the modulus of gradient of f. This is basically, in fact, not just any direction but rather unit normal direction. So this is also basically the unit normal direction. Okay. So this is unit normal direction. Now let us see for what of these questions, what answer you are supposed to give. What are the possible answers? Let us see all those cases. Okay, the first one. First one. If the question is find unit normal, find unit normal to f is equal to c surface. So this is a surface given to you. F is equal to c surface. Let's look at some question also. You know, this is one question. There is a surface, some function, okay, function of x, y, z is equal to constant value 7. So this is a surface given to us and you are supposed to find out what? Normal to that particular surface. So this is the kind of question I'm talking about here. So whenever find unit normal to a particular surface, okay. So in this case, the answers are nothing but you'll have two possible answers. One is plus or minus n cap, okay, plus or minus n cap. Two possible answers you're having. And it need not be unit. If the question is unit normal, it has to be n cap only. And how do you find out this? You find out this by means of gradient. Okay. So this is gradient of the function divided by the modulus of gradient of the function, entirely calculated where? At the given point of interest. Okay. So this is the logic. But here please notice there are two possible answers. Here in this case, there are two possible answers. What are they? Both the positive as well as negative. Positive vector is one direction, Negative vector is exactly opposite direction, also is basically normal to a surface. Okay. And next kind of question is nothing but direction of maximum increase of the function. Find, let's assume, unit normal uh, along maximum increase of maximum increase means maximum ascent also, maximum ascent of the function f. Now here we will take only the positive sign, guys. Okay, we will take only the positive sign term here, plus there will be only one answer here, gradient of f divided by modulus of gradient of f. Okay, and if the question is all about maximum descent, let's say third case, find the unit normal along the direction of maximum decrease or descent, maximum decrease of the function f. Now this could be equal to here minus of gradient of f divided by the modulus of gradient of f. Okay, so notice for increase, for maximum increase or ascent, we are taking a positive sign. For decrease or descent, we are taking a negative sign. And if the question is all about unit normal, just unit normal, nothing else, okay, perpendicular to or unit vector in other cases, no, it's not just unit normal, it is simply unit vector. In the first case, it was normal. In the second case, it was simply unit vector. So in the first case, it was basically now normal. If the question is unit normal to the given surface, in that case there are two possible answers. In the remaining cases, there are only one possible answer. In all the cases, in all the options, in all the times that we have got this question, find out unit normal to a particular surface. It was given as MCQs like this question, and all you have is nothing but only one single sign. The opposite sign term is not in the options, but that can be given as a question for you. Okay, so let us solve this question right now. Yeah, so there is a function, so this is a function and this is a constant. So obviously this is of the format f is equal to c. Is there any use of this particular constant in the given problem? No. Okay, no usage of that particular constant. Only thing is you can substitute this point in that particular function and verify LHS becomes equal to RHS. Apart from that, there is no usage of that particular function. Okay, so what is the here they simply ask you vector. It is not a unit vector. Okay, this vector is basically not unit vector. So means I have to first of all calculate gradient, and any vector in the direction of gradient or opposite direction of gradient are basically normal to the given surface. Okay, so what is the gradient of the given function? Gradient of f. Since the given function is in terms of rectangular coordinate system, I will be using the formula for gradient in rectangular coordinate system, dou f by dou x, x cap, plus dou f by dou y, y cap, dou f by dou z, z cap. When you differentiate the function with respect to x, okay, partially with respect to x, yeah, differentiation of 2x z square is nothing but 2z square, first term. Do we have, yeah, other x term we have differentiation of 3xy with respect to x is 3y, so minus 3y, and differentiation of 4x with respect to x is 4, so minus 4. So this is overall the x cap term. What about the y cap term? Differentiation of first term with respect to y is 0, second term with respect to y is minus 3x. Differentiation of the function with respect to z, only here we have z terms. Differentiation of z square is nothing but 2z. So 2z into 2x is nothing but 4xz. Direction is z cap. Okay. And the point of interest is 1 comma, point is 1 comma minus 1 comma 2. So yeah, here what is the answer now? 2z square, 2 into 2 square is 4, 2 into 2 square, 2 into 4 is 8, minus 3 into y, 3 into minus 1, minus 4 x cap, plus minus 3x is minus 3 into 1 minus 3 y cap plus 4xz. Xz is nothing but 2. 4 into 2 is 8 times z cap. So this overall becomes equal to 8 plus 3, 11. 11 minus 4 is 7. 7x cap minus 3 y cap plus 8 z cap. Okay, so this is the correct answer. Yeah, in 2019 we didn't have MSQ, so I don't have to verify other options. Now what could be the other options here? Anyone? What could be the other correct answers for this question? Plus, minus, apart from that, what else could be the correct answers? I have 7 minus 3, 8. I got the option C as the correct answer. Done. But what could be the other correct answers here? The other correct answers here are any other vector which are parallel to this, parallel to or anti-parallel to the given vector are also the correct answers, right? Okay, there is also one more question from Avinash. You said that cylindrical coordinate system rho is the distance from z-axis, but while conversion from rectangular to cylindrical, you take only the xy plane. Okay, I'll answer the question by taking this diagram. Imagine that this is a cake. This is a cake. Basically a cylinder. Cake makes it much easier for you to understand that. So here the point I have taken is nothing but, this is completely unrelated question for this problem. This is the point, and I told you earlier that boss distance of the point P from the z-axis. This axis obviously is nothing but z-axis. This axis is z-axis. And how much is this value? Distance of the point P from z-axis, I have told you that this would be known as rho. And I have done that same calculation also on the xy plane. I have taken this distance also as nothing but rho. Don't you think both are exactly one and the same? This distance and this distance, which is the radius of the cylinder, the radius of cylinder, will it not be same? Yes. If I have to do the analysis only on a 2D plane, which is basically xy plane, let's assume, okay, like this. So in that case, yeah, distance of on xy plane, what is the z-axis point? On xy plane, the z-axis point is nothing but origin only. When seen from top, the z-axis is basically a point for you. So because of that, distance of any point on the surface of the cylinder from the origin becomes equal to how much? Rho. Okay, rho, which is also same as the actual definition, which is in general definition, which is distance of a point P from z-axis is nothing but rho. And same discussion when you do on xy plane. So distance of the projection of point P, which is P dash now, that is not point P, understand, that is projection of point P from origin, okay, corresponds to the parameter called as rho. Okay, same diagram, if I ask you what is R, this is R, this is R. So in case of R, there is nothing called as projection. You are directly measuring the distance of the point P from origin only. Okay, directly distance of the point P from origin corresponds to R. But if you are, let's assume, discussing cylindrical coordinate system on xy plane, then obviously I have to take projection. Now I'm not talking in terms of point of interest, but rather I'm talking in terms of projection of point of interest on xy plane, and that distance from origin also corresponds to the same distance. Okay, I hope your doubt is cleared, Avinash. Okay, yeah, let us go for the next question. Yeah, unit vector normal to the equipotential surface of some function is given at some point is given as so and so value. Okay, and all you are supposed to find out is nothing but modulus of b. Only one component you are supposed to find out, only the b component is what you are supposed to find out. But here you have been told that whatever vector you are taking is nothing but unit normal vector, unit normal vector. So unit normal vector, what is the expression now? The expression is nothing but n cap becomes equal to gradient of the function divided by the modulus of gradient of function plus or minus. But anyway, all I have to do is nothing but find out only the modulus of b. So this plus or minus is of no relevance for us. Only the magnitude is what you're supposed to find out. And this becomes equal to, what is the gradient of the given function? Let us do the calculation first of the gradient. Okay. Again, the data is given in terms of rectangular coordinate system. So what is gradient of the function f now? This becomes equal to, formula remains same, dou f by dou x, x cap plus dou f by dou y, y cap plus dou f by dou z, z cap. Okay. And this becomes equal to, if you differentiate the function with respect to x, there is only one x term, 8x, x cap. With respect to y, 2y, 2y, y cap. With respect to z, there is only constant 1 times z cap. Okay. Now substitute the point of interest here. The point of interest is given as 1 comma 2 comma 1, which becomes equal to 8 into 1 is 8 x cap plus 2 into y is 2 into 2, which is 4 y cap, plus lastly we have z cap. So this is gradient. Substituting the value here, the gradient value here, then you get the answer as, this is plus or minus, this is plus or minus 8 x cap plus 4 y cap plus z cap divided by square root of 8 square plus 4 square plus 1 square. And from this, I want only b. B is what? Coefficient of j cap, which is nothing but y cap in our language. And if you compare those two guys, okay, the coefficient of y cap is nothing but b, and that coefficient here is nothing but what? 4 divided by some value. And from this b value is simply the magnitude. So magnitude corresponds to how much? 4 divided by square root of 64 plus 4 square is 16, I think. 64 plus, I think 80 plus 1 is 81. So square root of 81 is nothing but 9. So answer is nothing but 4 by 9. You have to express it rounded off to 2 decimal places. So finally, what do we get? Yeah, 4 by 9, correct? 0.444. Okay, so 0.44. You can round off to 0.44 as a correct answer, right? Yeah. Yes. Next question. Next is another one of the most important, topics. See, the thing with the gradient is nothing but gradient questions. Nowhere in the question you see the word gradient, but still you have to use the concept of gradient. For example, in the previous question, it was a previous GATE question only. Anywhere in the question do you see the word gradient? No, but ultimately you have to solve this question by using the gradient concept only. So same with next one also, directional derivative. Here also in these questions, nowhere in the question you see the word you see the word gradient, but still to solve these questions you are supposed to use the concept of gradient. And anyway, what is directional derivative? It is space rate of change of a function along a specified direction. Okay, along a specified direction. So in case of directional derivative questions, there are 3 things given to you. What are the 3 things given to you? One is nothing but function. Okay, so directional derivative of basically so directional derivative of the scalar function f at a particular point in space. So if you see scalar function, this is the first thing given to you. Okay, second thing is nothing but direction is given as u bar or u cap. Sometimes it is given as u bar, sometimes it is given as u cap, and at a particular point in space. So these are the 3 things given to you. And yeah, you are supposed to find out what is the directional derivative of, that is the space rate of change of the function f along u bar direction, and entire analysis is being done at the point of interest p is what, and the formula is given by the dot here. There should be a dot. So this is given by simply gradient of f dot u cap. Okay, u cap. In this case, you are using u cap. What is u cap? U cap is nothing but unit vector. This is unit vector of the direction which is given to us u bar. And how do you calculate that u cap? Obviously, u cap can be calculated as u cap is equal to u bar divided by the modulus of u bar. Okay, so here first you have to calculate u cap. Second, you have to calculate gradient of the function at the point of interest, and then take dot product. to get the directional derivative of the given function at the given point along the specified direction. Okay, yeah, let us look at the questions here. Very recent question, easy, I think 1 mark question this was. It was a 1 mark question. The rate of increase, please notice, increase means what? I will take only the positive number here. Okay, I will take only the positive sign. Rate of increase of a scalar function. So function is given to me as nothing but x, y, z. In the direction v, the notation used by examiner is nothing but v. So what is the meaning of this v? V given as some 2, 1, 1 means v bar becomes equal to, according to examiner, 2x cap plus 1 y cap means y cap plus 2 z cap. Z component is nothing but 2 means 2 z cap. So means what is v cap right now? V cap is v bar divided by the modulus of v bar, which becomes equal to, this is 2x cap plus y cap plus 2z cap divided by square root of 2 square is 4, 1 square is 1, 2 square is again 4. So finally we have v cap being equal to 2x cap plus y cap plus 2z cap divided by square root of 4 plus 1 plus 4 is nothing but square root of 9. Square root of 9 is 3. So first part of the problem is done. So this is a 3-step problem from now on. So the first step is nothing but calculate the unit vector along the direction specified. Done. Next is we have to calculate gradient of the function. Gradient of the function becomes how much? Formula, rectangular coordinate system, dou f by dou x x cap plus dou f by dou y y cap plus dou f by dou z z cap. Okay, and if you substitute the values x y z, function value is x y z. Differentiating x y z with respect to x becomes equal to y z x cap plus differentiation of the function with respect to y is x z y cap. Differentiation of the function x y z with respect to z is x y z cap. Now substitute the point of interest. What is the point of interest? 0, 1, 0, 2, 1. So this is the point of interest. If you substitute this, what do we get? So yz is 2 into 1. 2 into 1 is 2 times x cap plus x into z is 0. X into y is also 0. So 0 y cap plus 0 z cap. So because of cancellations, you are left out with only 2x cap. 2x cap is the only term remaining for you. Okay. So step 2 is complete. You have calculated gradient at the given point of interest. Now next what was asked for you? Directional derivative, right? So directional derivative or rate of increase. Okay, rate of increase of the function f along u bar or v bar direction here at the given point of interest is given by what now? This is equal to gradient of the function at the point P dot v cap. So all you have to do is nothing but take dot product of this vector and this vector. If you take dot product, what will you get? There are only x components, no? X component here is nothing but 2, there x component is 2 by 3. So all you have is nothing but 2 into 2 by 3 becomes equal to how much? 4 by 3. Okay, repeatedly asked question this is. So this is finally 4 by 3, right? Yeah, go to the next question. Next, the value of again directional derivative of the function. Again, nowhere in the question you see the word gradient. Ultimately, you have to solve it by using the concept of gradient. So function is given. Function is denoted as phi here by the examiner. So function is given to us, and then point is given, and then direction of the vector. The notation used by examiner is nothing but p bar is also given to us. Okay, and then you are supposed to find out directional derivative. Yeah, so let's follow with the usual process. I'm using my own notation. My notation is u cap becomes equal to u bar divided by modulus of u bar, which becomes equal to direction. Direction is given as x cap. Examiner notation is ijk, my notation is xyz. I'll always use my notation while solving questions in exams also. Plus 2 z cap divided by square root of 1 plus 4 plus 4 1 plus 4 is 9. Square root of 9 is nothing but 3. So this is x cap plus 2y cap plus 2z cap divided by 3. And then we have the gradient of the function. What is the gradient of the function? In this case, function is phi. I am calling it as f, doesn't matter. Formula is dou f by dou x. In exam, it may take maybe half minute of time more, but until you are comfortable with, don't miss the formula. Write the formula. Don't have to substitute. Directly you can do the calculation, but writing this extra step will not waste a lot of time for you. Sometimes people directly write the answer. Okay, so in the process, maybe they are saving some time, but there is also a possibility of silly mistake in an easy problem. Okay, don't do that. When you differentiate this guy with respect to x, we get y square here, we get 2xz here. So this is y square plus 2xz x cap plus differentiation with respect to y. Here we have 2xy and here z square. So this is z square plus 2xy y cap plus, if you differentiate with respect to z, here we have x square plus 2yz. So x square plus 2yz. And what is the direction? Direction is z cap. Okay, z cap. And substitute the point of interest. What is the point of interest? The point of interest is 2 comma minus 1 comma 1. Okay, upon substitution, what is the answer you get? Think, yeah. What is the answer here? Y square is nothing but 1. So this is basically 1 plus 2xz. Xz is nothing but 4. Sorry, 2. 2 into 2 is nothing but 4. 4 x cap plus y cap. Z square is nothing but 1. 2xy. Xy is minus 2. Minus 2 into 2 is nothing but minus 4. So we get 1. This is 1 minus 4 y cap plus lastly 2yz. What is 2yz here? Sorry, what is x square? 2yz is nothing but y is minus 1, z is 1 minus 1. So this is minus 2. I'm sorry. Yeah. So we get first of all x square. X square is nothing but 4 minus yz is nothing but minus 1 into 2 is overall minus 2 z cap. Okay. And finally, what is the expression we have got? The expression is 5x cap minus 3y cap plus 2 z cap. Okay. So this is the gradient. And finally, when you combine both of them, or this question is all about what right now? This is gradient of f at the point of interest dot u cap, and that becomes equal to when you take dot product for the given scenario. Okay, dot product for the given two vectors. What do we get? 1 into 5 is 5. 2 into minus 3 is minus 6 plus 2 into 2 is 4 divided by 3. 5 plus 4 is 9. 9 minus 6 is 3. 3 by 3 is nothing but 1. So the answer is nothing but 1. Yeah, we have one of the options as nothing but 1. Okay. So again, these are pretty much straightforward questions. But nowhere in the question you see the word gradient, but still you have to solve this question by using the concept of gradient only. Okay. Yeah. Simple question this is. Let's go for the next one. Yeah, good. Yeah. Again, in this question, if you see, there is another question like this only, next one also. I think, yeah, this one also same problem. Nowhere in the question you have been given direction directly to you. Okay, so how do you solve this? This is another new model. Previous one, direction was directly given to you. So in this question, direction was not given to you. So how do you solve this question? Directional derivative of the function. This is the function now. Okay, so this is the function. Point is given to you. Yes, entirely in terms of 2 dimensions. So point is also given. But direction is not directly given to you. Okay. You have been told that, boss, you are starting from some initial point, going to some final point. So in this case, yeah, please, find out what is the directional derivative. Okay. So in this question, what you are supposed to do? The logic in this question is nothing but, you have to find out the direction vector directed from the first point to second point. Usually, whenever we find out direction vector, okay, so here extra discussion. Direction vector from, in 3 dimensions I'm taking, the point x1, y1, z1 to x2, y2, z2. This is nothing but x2 minus x1 x cap plus y2 minus y1 y cap plus z2 minus z1 z cap. That's it. Nothing else you have to do. All you have to do is nothing but this. So on the basis of the given data, now what is u bar? U bar, which is a direction vector directed from first point to second point. x1, y1 are 0, 0, x2, y2 are 1, 1. So this becomes equal to 1 minus 0, which is nothing but 1. 1 minus 0 times x cap plus 1 minus 0 times y cap. And this u bar becomes equal to x cap plus y cap. Okay, so this is basically u bar. But do I want u bar? No, I want u cap, because the here also I'm supposed to find out directional derivative, means I'm supposed to find out u cap. What is u cap right now? This is x cap plus y cap divided by square root of 1 square plus 1 square, which is overall square root of 2. So I'm done with u cap right now. This u cap until now have been directly given to us. Sometimes this will not be directly given to us. So this is what you are supposed to do in order to get the answer here. Okay. Yeah. So what is gradient right now? Gradient. I'm writing this a bit directly right now. Differentiation of the function with respect to x becomes equal to 2x. So this is 2x is the x cap term. Differentiation of the function with respect to y is 2y. So this is 2y times y cap. Point of interest. What is the point of interest? 1, 1. If you substitute 1, 1, you'll get it as what? 2 into 1 is 2. So this is 2x cap plus 2y cap. Okay. And finally, what is directional derivative? Directional derivative is what? So this is gradient of f dot u cap. Okay. And this becomes equal to, yeah, if you take dot product of both, there we have xy, here also xy only, 2 into 1 2, 2 into 1 2, divided by denominator root 2. So we have 4 by root 2, 4 by root 2 becomes equal to 2 root 2. Okay. Yeah, answer is nothing but A. But in this question, if you see, directly it was not given what is u bar. U bar you have to find out by using the this particular logic as to how to find out direction vector directed from point 1 to point 2. Okay. But again, you can also do that, Avinash, but that is a line. I require line in line integrations. Okay, equation of a line is required in case of line integrations. Here, we have to find out the direction vector. I want a vector, no? Okay, if you look at the standard structure of directional derivative also, Avinash, yeah, what are you supposed to get here? Direction. This direction is not a line. This is a vector. You have to get this vector. So from point 1 to point 2, you have to write it as a vector format, not as a line format. Okay. Yeah, wrong. That is wrong. Correct. Now try to answer this question. Same logic. Same logic. Again, vector given to you. Yes. Slightly complicated vector though. Okay. X e power y. So when you differentiate that function with respect to x, so dou f by dou x would be how much? Differentiation of this function with respect to x is nothing but e power y. And if you differentiate this function with respect to y, dou f by dou y becomes how much? X into differentiation of e power y. Differentiation of e power y with respect to y is y only. Sorry, e power y only. So this is still x into e power y. Okay. Yeah. So we are done with gradient right now. Yeah. sorry. Yeah. So initial point is given. This is x1 comma y1 and this is x2 comma y2. By using these two guys, can you find out what is directional derivative now? U bar. What is u bar? U bar is equal to x2 minus x1. So which is nothing but half minus 2 x cap plus y2 minus y1. 2 minus 0. So this is 2 minus 0 y cap. So u bar finally becomes equal to half minus 2 is nothing but minus 3 by 2. So minus 3x cap by 2 plus 2 minus 0 is nothing but 2 only, 2 y cap. But again, I want u cap. So what is u cap? U cap is equal to, anyway, what I'll do is I can further write this as also, just for simplifying my calculations, I'm taking LCM. If you take LCM, this is minus 3x cap plus 2 into 2 is nothing but 4 y cap divided by 2. Okay. So what is u cap then? U cap, denominator anyway is nothing but 2. Let's not disturb it. So minus 3x cap plus 4 y cap divided by 2 divided by, see, 3x cap plus 4 y cap magnitude, if I find out, the magnitude of that guy is nothing but square root of 3 square plus 4 square, which is nothing but 5. So divided by 5. So overall we have this expression of u cap to be equal to minus 3x cap plus 4 y cap divided by 10. Okay, so I got my u cap. I more or less got my gradient function also. Gradient of f becomes equal to, now differentiation with respect to x is e power y x cap. With respect to y, differentiation is x e power y cap. So this is a gradient function. And when you substitute the point given to you, point is basically half comma 2. So half comma 2 is the, point is 2 comma 0. The point of interest is basically this guy. This guy is point of interest. So 2 comma 0, when you substitute, you get the answer as nothing but, now gradient of the function becomes equal to e power 0 is nothing but 1. So x cap plus x is 2. So 2. E power y is e power 0. E power 0 is 1. So y cap. Okay. So we got gradient function also. And finally, what is directional derivative then? See, what is the purpose of giving this e power y? Ultimately, that e power y is not coming in the final answer, just to scare you. So whenever they give you some kind of a slightly complicated looking function, the main intention is to scare you. If you are scared, means examiner is happy, the purpose of examiner is satisfied or justified. So next is directional derivative. Directional derivative becomes how much right now? Yeah, this is gradient of the function dot u cap, not u bar, u cap. So every time you have to calculate u cap first and then proceed with the problem. If you take dot product, you get minus 3 into 1 is nothing but minus 3 plus 4 into 2 is 8 divided by 10. Oh wait, I'm sorry, I think there is a mistake I've done. Yeah, I've done a small mistake here. Okay. So here, this is 5 by 2. The magnitude here is 5 by 2. This is 5 by 2. So because of which denominator here becomes equal to 5. This is 5. Okay, it's my mistake. It has to be unit vector. No, magnitude is not 1 here if you notice. Magnitude is how much? Square root of 5 by 5. Now it is 1. Correct. So 2 and 2 is gone. All you have is nothing but minus 3 x cap plus 4 y cap divided by 5. And when you do the calculation here, denominator now becomes equal to not 10 but rather 5. So this is 5. Okay. Now, then what is the answer? So 8 minus 5 is nothing but 5 by 5. Overall, the value is nothing but 1. Okay. So in this case, it's a pretty recent question. In fact, answer is nothing but 1. This is electrical 24 2-mark question, again directional derivative. You see that this is one question that more or less comes every year. At least EC electrical, I can tell you, every alternate year, like in EC paper every alternate year. Again, electrical paper, every alternate year you see a question on basically this, directional derivative. In 2024, we didn't get a question on directional derivative. 2023, we have got a question. That is one of the problems we have done earlier. And if you look at the previous years again, this was 2023 EC paper. 2021, again we had a question on directional derivative. Okay. So 2024, going by that logic, 2025, definitely there is a possibility in EC paper, this question on directional derivative. But yeah, the question looks a bit complicated. Complication occurs where? At the function level. Okay. Function looks complicated. So point is given, where is a point? X, Y, Z point is nothing but 1, 1, 1. Direction is also given for us. Yes, U bar direction is also given. Okay. So by now, magnitude of that particular U bar is how much? Square root of 2 square plus 1 square plus 2 square, square root of 9, 3. So magnitude is not a big deal right now. Okay. So now what is U cap? U cap is simply equal to U bar divided by the modulus of U bar. Okay. And this becomes equal to how much? 2, 1, 2. So 2x cap plus y cap plus 2z cap divided by 3. Magnitude is nothing but 3. So we are done with U bar. Now the main part is calculating gradient of this function. Okay. What is dou f by dou x? Let me calculate these things first before we calculate gradient. Dou f by dou x becomes equal to, there are x terms here and here. So this is 2 ln of xy, differentiation of ln of xy is nothing but 2 by xy into differentiation of xy with respect to x becomes equal to y. Okay. Similarly, next what do we have? This is 3 differentiation of ln of xy, differentiation of ln of something is nothing but 1 by that xz term here, and differentiation of xz with respect to x becomes equal to z. So on the basis of this, we have got 2 by x plus 3 by x, which is basically 5 by x. 5 by x. Substitute the point. What is the point for us? 1, 1, 1. So it becomes equal to simply 5. And then dou f by dou y. If you differentiate the function with respect to y, where do we have y terms? The first 2 terms. So 2 by xy. If you differentiate ln of xy, we get 1 by xy. So 2 by xy, coefficient is 2. Differentiation of xy with respect to y is x plus, next, differentiation of ln of yz is 1 by yz, and differentiation of yz with respect to y is z. Okay. So here what we have? So z, x gone. 2 by y, 1 by y. Total we have got 3 by y. So this is equal to 3 by y. Substitute the point also. No, point is 1, 1, 1. Okay. So when you substitute the point also, then the answer that you get is y is also 1. So this value becomes equal to 3. The last one is dou f by dou z. Okay. If you differentiate this guy with respect to z, there is no z terms in the first one. Z term is there here. 1 by yz. Differentiation of yz is equal to y. Let's differentiation of ln of xz is nothing but 1 by xz. Differentiation of xz with respect to z becomes equal to x. Okay. So y, x. So finally this becomes equal to 1 by z, 1 by z, 2 by z. Okay. And since the point is nothing but 1, 1, 1, so this becomes 2. You can solve with me parallelly. So finally the x component is 5, y component is 3, z component is nothing but 2. Okay. So accordingly we get gradient of the function at the given point. Directly the point also has been substituted, becomes equal to 5x cap plus 3y cap plus 2z cap. So this is the gradient function. And lastly, what is the directional derivative? Directional derivative is basically gradient of f dot u cap, obviously at the point P. So when you take dot product, what are the x components for both cases? X component here is 2, there it is nothing but 5. So this is 2 into 5 plus y component here is 3 and there it is 1. 1 into 3. This is 1 into 3 plus z component here is 2. There also I think is 2 only. Yeah, 2. Both are 2. So this is 2 into 2 divided by denominator is nothing but 3. Yeah, if you do the calculation, 10 plus 3, 13, 13 plus 4 is I think 17, 17 by 3. What is the answer? Oh, okay. Did I do anything wrong? All of you are getting 7, huh? 7, I got a different answer. 5 by x, 3 by y. Oh, okay, z, I have done mistake in z. Here it is 3. I'm sorry, my mistake. Okay. So this is 3 by yz. 3 by xz it should be, sorry, so z part is wrong. 1 by yz coefficient is 1 only. So z part is this. Yeah, got me. So this is 3. So means overall this becomes equal to 1 plus 3 is 4. This becomes equal to 4. Okay, 4, and hence this becomes equal to 4. So this is 2 into 4. I'm sorry, this should be 2 into 4. So 10 plus 3, 13 plus 4 is nothing but, yes, 13 plus 8 is nothing but 21. So this is now 21 by 3. Answer is 7. Okay. In this question also the logic is not tough. The same age old logic we are having, but only thing is the function was given a bit complicated. So because of which the initial reluctance people will have. Array, it looks very complicated. So let us not answer the question right now. We'll answer the question maybe at later point of time. And people leave this question without solving it in the beginning. It's a 2-mark question, and that too, a routine model only. It's not a new model, it's a routine model. So these kind of things you should not leave it in the first 1 hour. First 1 hour, this kind of questions is what you are supposed to do. Repeated models. Okay. Yeah. So let's go for the next topic now. Let's go for the next topic. Next we have divergence theorem. Every year if you see divergence theorem and Stokes theorem, one question you are having. Okay. So this is one more area where it will give you at least 1 mark for you, 1 or 2 marks. Usually when you get questions on both line integrations, Stokes theorem or divergence theorem, they are usually 99% asked for 2 marks, 99%, unless it is a theory question. If it is a theory question, it will be asked for 1 mark. Last year only, this year only we have an easy paper. But rather, yeah, if it is a numerical question, there is a very good chance that it will be given for 2 marks usually. Okay, let's go for that. So yeah, what does divergence theorem do? So divergence theorem basically converts the closed surface integrations into volume integrations. Closed surface integrations are very lengthy integrations. They take a lot of time. Okay, so these guys are basically lengthy integrations. In GATE exam, you cannot solve, at least for most of the problems, the closed surface integrations by using closed surface integration approach within the time frame. There is a time frame for you, so within the time frame you cannot solve the questions by using the surface integration approach. So then wherever you see the surface integration question, that too closed surface integration question, you think that you have to probably use divergence theorem. Okay, and you have to use divergence theorem only when the surface is closed. If the surface is not closed, you cannot use divergence theorem to solve that particular question. Okay. Next is divergence. What does divergence measure? Divergence measures something known as net outwardness of a particular field. So if I want to know whether the field is really outward or inward, outgoing nature, incoming nature, or neither outgoing nor incoming nature, in that case, I find out that by using the concept of divergence. Okay. So let's first of all see divergence theorem. So divergence theorem says that there's a small missing data here. Yeah, divergence theorem says that the closed surface integration of A bar which is given by a bar dot ds bar. Okay, so integration of a bar dot ds bar is nothing but the so-called closed surface integration of a bar. This is basically closed surface integral of a bar Sometimes this is also given to you as nothing but flux coming out of S. So this is also equal to the flux out of the surface S due to the vector field which is nothing but a bar. Okay. Yeah. Now the RHS part becomes equal to, this is equal to, now it's a volume integration right now of not a bar but rather divergence of a bar. So here on the RHS what we have is nothing but this is volume integral of divergence of a bar, okay, over the volume enclosed by the closed surfaces. Okay, so this is what is the divergence theorem, and to solve divergence theorem questions you require divergence formula also. So let us look at even divergence formula in curvilinear format. So this del dot A, this expression basically is del dot A. So del dot A means, this is a notation that we are using for divergence of A. Divergence of A bar. Okay, so this is given by 1 by, here remember only the first part. If you can remember the first part, no, writing the second and third is not a big deal. By means of cyclical symmetry we can get the second and third part also. Okay, so this becomes equal to 1 by h1 h2 h3, which is multiplication of scale factors into common term dou by dou u, differentiation with respect to the first variable. In case of rectangular it is x, in case of cylindrical it is nothing but rho, in case of spherical it is nothing but r, h2 h3. So these are the scale factors for v and w. So other than u scale factors, u scale factor is h1, so other than h1 you are having h2 h3, multiply them into au. Au is nothing but the first component of a bar. You are taking a vector field a bar, no? So this vector field a bar will have three components. What are they? Au times u cap plus av times v cap plus aw times w cap. So we have the components of vector field. So you are multiplying h2 h3 with the u component of the u component of the vector field given to us. Okay, so let us by using this curvilinear formula. Now the moment you get the first one, second one is you are differentiating with respect to v. Scale factor of v is h2, other than h2 we are having h1 h3 multiplied with the corresponding component of v is av. And lastly, differentiation with respect to w. W scale factor is h3, other than h3 you are having h1 h2, multiply them, multiplied with the component of what is the vector field that we are differentiating right now, that is nothing but w component, so aw. Okay, so that's it. So this is the expression we have for divergence. So divergence theorem do require divergence theorem. Whenever you want to use divergence theorem, 100% you are supposed to know the divergence formula also. Okay, yeah, the curvilinear formula that we have taken earlier, if you apply that in all the three coordinate systems, okay, don't have to mug up. So this is definitely not for mugging up, not required also. I'm just showing you how that formula is used. First case, scale factors are ones, right? So all you have is nothing but dou by dou x of ax, dou by dou y of ay, dou by dou z of az. If you substitute u, v, w as nothing but x, y, z and h1, h2, h3 as nothing but ones. Next case, if you substitute h1, h2, h3 as nothing but 1 rho 1 in cylindrical, 1 by rho you are having. Dou by dou rho of h2, h3 is rho times a rho. Since you are differentiating with respect to rho, a rho. And next here h1, h3 both are ones, and hence 1 into the scale, the differentiation is with respect to phi and hence a phi component. And lastly you are having here h1, h2. h1, h2 is nothing but 1 into rho into you are differentiating with respect to z, az. So that's what you have taken. Now here what you can do is you can expand the bracket terms. If you expand the bracket terms here, you are differentiating with respect to z. Rho is constant, rho is taken outside. So rho by rho is nothing but, yeah, there is no coefficient here. Here, yeah, you are differentiating a phi with respect to phi, dou a phi by dou phi, 1 by rho is the coefficient. Here anyway, you are differentiating, the integrand is, differentiation term is not changed, rho a rho only, that is taken here also. Coefficient is nothing but 1 by rho. Same thing we have done in case of spherical coordinate system. In spherical coordinate system, h2, h3 terms are nothing but r sin theta, multiply them, r square sin theta. h1, h3 is nothing but, h1 is 1, h3 is r sin theta, so r sin theta here. h1, h2 is nothing but 1 into r. So that's what you see here, okay. That's it. When you expand the brackets again, first one, differentiation with respect to r, sin theta is constant taken outside. If you take that outside, sin theta by r square sin theta is 1 by r square, you have this formula and so on. Okay, so this formula now is not a big deal, because don't look at them as separate formula. All you have to do is remember this formula and remember the scale factor table. Then getting the divergence expression in all the three coordinate systems is not a big deal for you. Okay. Yeah. So let us look at a few questions. The first question: integration of a particular vector field. Okay, that vector field is known as r bar, and r bar is given as this guy, which is also known as position vector. This guy is also known as position vector. Yeah, it's given anyway. Where r bar is the position vector. I think that word is missing. Position vector in rectangular coordinate system. Okay, is dash. So if you see the notation of the examiner used what notation? Yeah, integration of, I'm rewriting it in my own notation, r bar dot ds bar. Whatever is ds bar that you have here, ds bar is nothing but ds times n cap or n bar. This n bar is nothing but normal direction. And you have been very clearly told that, boss, you're having a closed surface. So whenever I see this, I can use divergence theorem. Okay, I can use divergence theorem here. By applying divergence theorem, what do we get? Yeah, we can write it as integration of del dot r bar, divergence of r bar into differential volume over the volume V. Okay. Now let's calculate divergence for the given vector field. The given vector field is in terms of rectangular coordinate system. So in rectangular coordinate system, what is divergence of r bar? So this is nothing but dou rx by dou x. Differentiate x component of r bar with respect to x. Differentiate y component of r bar with respect to y. Differentiate z component of r bar with respect to z. So this becomes equal to, when you differentiate the x component of r bar is what? X only. So this is rx, ry, and this is rz. Coefficient of x cap is nothing but rx, y cap is ry, z cap is rz. So we'll get 1 plus 1 plus 1, because when you differentiate x with respect to x, 1, y with respect to y, 1, z with respect to z again is 1. So total value is nothing but 3. Substituting the value here, we get the answer as what? This is nothing but 3 now. So this becomes equal to 3 times integration of dv. What is the integration of differential volume? Total volume. So this becomes equal to total volume given to us, which is nothing but v. So answer is how much now? This is 3v. Right? Simple question, nothing great. If this is the kind of question that you are getting, generally this will be given for 1 mark, because not much of a calculation. Okay. Yeah. Next one. You have been given again a vector field, and you are supposed to calculate the surface integral of a vector field over the entire surface area of the cube, over the entire surface area of your cube. Consider a cube. Cube is nothing but open or closed surface. You tell me. Cube is definitely a closed surface, right? This is basically closed surface. So nowhere in the question the examiner used the word closed surface integration, but ultimately this is a question of closed surface integration, because you have been given the shape as nothing but a cube, and you are supposed to do the integration over the entire surface of the cube, not just on 1 or 2 or 3 or 5 surfaces, but rather all the 6 surfaces of the cube you are supposed to perform the integration. So if you rewrite what was given to you in the data, the question is all about, boss, please perform integration of f bar over the surface. And what is this closed surface S known as? This closed surface S is known as cube right now. So this is basically the so-called cube. Okay. So now please do the calculation. Again, I see closed surface integration. I can apply divergence theorem. If I apply divergence theorem, yeah, I can write it as integration of del bar dot f bar into dv over the volume v. So to calculate this integration, I'm supposed to calculate right now divergence of f bar. Coordinate system is rectangular coordinate system. Del dot f becomes equal to dou fx by dou x plus dou fy by dou y dou fz by dou z. Okay. Yeah, when you differentiate x component, what is x component of f bar? So x component of f bar is 3x, this is fx, and this is fy, and this is fz. So you have to differentiate x component with respect to x, y with respect to y, z with respect to z. When you differentiate x with respect to x, we get 3, y with respect to y is 5, and z with respect to z is 6. So 5 plus 3 plus 6 becomes how much? This is 8 plus 6, 14. This is 14. And when you substitute this value here, you get the answer as nothing but this is 14 times. Yeah, I have now divergence value as a constant. So if this divergence value is a constant 14, and if I substitute that here, so this becomes equal to now 14 into, what is integration of dv? Integration of dv is nothing but volume. Whose volume? Volume of the cube. Do we have the information of volume of the cube? Consider a cube of unit edge. Okay, this part is important. Unit edge length. So means the side length of a cube is nothing but 1. So what is the volume of a cube whose side length is nothing but 1? So this becomes equal to a cube, which is equal to 1 cube, which is equal to 1. If this is given as 2, probably you will get maybe 2 cube 8 value. Okay, but anyway, in the given case, if you do the calculation, all you get is nothing but 14 into 1, which is nothing but 14. Okay, so do we have that option? Yes, option. Okay. But if you do the same problem by using surface integration approach, it will take a lot of time, because you have to now perform 6 integrations. Not so easy to calculate 6 integration in the given exam time frame, because for a 2-mark question, you will be hardly having something around 3.5 to 4 minutes of time, not more than that. So you can't solve surface integration within the 3.5 minutes of time, no matter how fast you are. Okay. So hence, to solve this question within the time frame, you have to use divergence theorem. Next. Yeah, you guys solve this question now. Yeah. Again here, this is a vector field. You have to understand that this is n cap, and this entire term is nothing but ds bar. You have to visualize that. So you have been given integration of a bar dot ds bar basically here. Okay. And whatever surface given to us, what is the surface? Please look at. This is what I was telling. The data was given to you in a different coordinate system. Yeah, you have been given a sphere. Okay. So this is basically surface S. Okay. And that surface S is nothing but a sphere. Sphere of radius how much? What is the radius of the given sphere? The general expression of a sphere is nothing but x square plus y square plus z square is equal to r square. So with radius r is equal to square root of 9. So because which the radius of the sphere is nothing but 3 units. Okay. So this will help us finally find out the volume here. So means examiner told us, boss, please calculate this thing. which is integration of a bar dot ds bar over a closed surfaces. Whenever you take a sphere, sphere is a closed surface or an open surface, just like a basketball, let's say. Basketball is a spherical surface, right? Is it open or closed? Is it not closed? Yes. Because does it not enclose a volume? 100% yes. Okay. So, I have to solve it by using divergence theorem. And by applying divergence theorem, this becomes equal to del dot a bar into dv over the volume V. Okay. So let us calculate divergence here again. Del dot A. What is del dot A? Differentiation of Ax with respect to x, Ay with respect to y, and Az with respect to z. Okay. So when you differentiate x component here is what? Whatever is 9x we have, the coefficient here is, yeah, this 9x is nothing but Ax, minus 2y is Ay, minus z is nothing but Az. Okay. So you have to differentiate Ax with respect to x, means this is dou by dou x of Ax is 9x plus dou by of differentiation of Ay is minus 2y plus dou by dou z of the differentiation of minus z is nothing but, or the z component is nothing but minus z. So this becomes equal to 9 minus 2 minus 1. So 9 minus 2 minus 1 is 6. This is nothing but 6. Okay. So which is what you will substitute here again. So this becomes equal to 6. I have this as constant. In all these cases, I'm having this as constant. Okay. So because which I don't even have to make use of dv here, but there are problems where you are supposed to use even dv. 6 into volume. What is the volume? Volume of a sphere now. Sphere of radius how much? Yeah, the surface is basically the sphere of radius 3. So what is the volume of a sphere whose radius is nothing but 3? 4 by 3 pi r cube, and r here is nothing but 3, so 3 cube. Okay. So if you do the calculation, what will you get? So this is 3 cancels out 6 2 times. Final answer here will be 27 into 8. .216 pi is what you get. 216. Okay. Yeah, 216 pi. Good. Lal Kumar, I think somewhere you have done a mistake. Please cross verify. Next question. Next. So after this surface integrations as well as divergence theorem and divergence, next we have Stokes theorem as well as the concept of curl. Okay. So Stokes theorem, what does Stokes theorem do? It converts, like in the previous case, converts closed path integrations right now. Now we are in path integrations. Closed path integrations are converted into surface integrals. Here, whenever I say surface integrals, always these are open surface integrals. Okay, always into open surface integrations. So here in this Stokes theorem simply says that, boss, whenever you are having a bar dot dl bar, so this closed path integration of a bar dot dl bar, which is also same as circulation of a bar. Okay, so this expression LHS is also known as, this is closed path integral of a bar around L. Sometimes we also call it as nothing but circulation, simply circulation of a bar along the path L. Now this also becomes equal to curl of a bar dot ds bar. So RHS, what do we have? RHS, we are having surface integration. So this is basically surface integral of curl of a bar So you're not integrating RHS. Your RHS integration is not basically integration of A bar, but rather it is curl of A bar over the surface enclosed by a closed path L. Again, you cannot apply the Stokes theorem on open surface integrations. Never apply Stokes theorem on open surface integrations. Sometimes, if you are lucky, maybe you will get the same answer, but rather that is not the way you are supposed to do it. Okay. Yeah. Next, the curl formula in case of curvilinear coordinate system is given by, this is 1 by h1 h2 h3, determinant of, we have scale factors in the first and last rows only, h1 u cap, h2 v cap, and h3 w cap, dou by dou u, dou by dou v, dou by dou w. Second row differential operators. Last one is nothing but the scale factor of h1 or u is nothing but h1. So multiply h1 with the same vector field component au. Second one h2 av, h3 aw as such. Okay. Now, yeah, by the way, what does curl measures? I forgot to mention. Curl measures the maximum circulation of any vector field. Okay, and the direction of curl is basically the direction of axis of that particular circulation by applying the right hand thumb rule. Okay, and by applying the previous curvilinear formula in all the three coordinate systems. For example, if you take firstly rectangular coordinate system, curl formula is given by h1, h2, h3 coefficients are nothing but ones. Outside also you are having one only, and then you are having ax, ay, az. Coefficients again are nothing but ones. In case of cylindrical, 1 row 1 coefficients, 1 row 1 coefficients. Outside you are having 1 by multiplication of scale factor 1 by row. Here 1 r sin theta, again 1 coefficient 1 r sin theta. Second row differential operators only, no coefficients. Outside 1 by multiplication of scale factors 1 by r square sin theta. So this is a curvilinear formula. So don't think of them as three different formula. This is basically this formula rewritten by substituting the corresponding scale factors, nothing else. Okay. Yeah. Okay, so before we do the problems, I'll take a small break, 10 minutes break. Okay, it will be a very short break for you. We'll be back within 10 minutes of time. Okay. Yeah. Yeah. Once the class is complete, I'll upload the PDF. Okay. Thank you. Okay. Okay. So let us continue from where we left off in the previous session. Yeah. So let's look at a few problems now. The problems on line integrations, yeah, they are a bit, uh, sometimes they'll be a bit confusing. Sometimes they are straightforward, and sometimes they look risky, but rather they are very simple only. So let's look at those questions now. Okay. So in the first case we have a open path integration. As you can see here, there is a path. So this path is denoted by C. So there is a starting point. Look at the arrow mark now. The arrow mark starts at initial value. This is the initial point and this ends here. So this is the final point. So this is basically a open path integration. So whenever the path is nothing but open path, and how do you identify open path? Initial and final points are not same. Okay. So here I can clearly notice that initial point is not same as final point. So because of which whatever is the path given to us is basically the path is open path. Okay. So to solve this question, you can't use Stokes theorem. So don't use Stokes theorem whenever the path given to you is nothing but open path. Okay. So let's proceed now. The vector field is given to us, and yeah, here in case of open path integrations or closed path integrations, the most important thing is always path for you. So identify the path. It is a parabola y equal to x square. Okay. So let me take the path first. So the path here is nothing but y is equal to x square. And line integration is basically a one-dimensional integration, surface integration two-dimensional integration, and volume integration is a three-dimensional integration. Okay. So why am I telling you that? Because here in this case, you are supposed to ultimately find out f dot dl. So let me calculate f dot dl. Let me calculate f dot dl here first. Okay. So f bar, x component of f bar is nothing but y, and this is I think ay. Okay, I'm sorry, this is ay instead of zy. Data given wrongly to you. This is not zy, but rather this is ay. Okay. So the y component is nothing but minus x. So whenever you take f dot dl, so this is fx times dx plus fy times dy, at least in case of a 2D system, because dl bar in case of rectangular coordinate system is nothing but dx x cap. So this dl bar becomes equal to, this is dx times x cap plus dy times y cap, dz times z cap, but we don't have any z terms here, so I'm stopping it here. And when you take dot product, so finally this is what you get. And what is fx right now? Fx is coefficient of x cap is y, so this is y times dx, and coefficient of y cap is nothing but minus x here, so this is minus x times dy. But if you notice here, how many variables do we have? We have two variables. So in the beginning always we will have only two variables, and it depends on anyway the problem. Sometimes you may have even three variables also, but ultimately you have to convert them into one single variable. Okay. And for that what we are doing is we are making use of this path information. Okay. So I have y. Can I replace y by means of x terms only? Yes. Wherever I see y right now, y is present here. So I'm replacing this y as nothing but x square. Now second, again we have dy. From this can I write dy also? Yes, I can find out dy in terms of dx. So here dy by dx becomes equal to how much? This is 2x. So due to which I can say dy becomes equal to 2x times dx. In case of open path integrations, this path information is very important. So I'm making use of this also here. Okay. So wherever I see dy, I replace that dy with respect to now 2x dx. So x into 2x dx. So x square dx minus 2x square dx is minus x square. So this is overall minus x square dx. So you have converted everything in terms of one single variable. So here you have to perform integration of f bar dot dl bar from where to where? from the initial point I to the final point F when you are moving along the path L, and this becomes equal to integration of now minus x square dx. So identify what is the value of x at the initial point. At the initial point, x value is nothing but -1. At the final point, x value is equal to 2. Okay. So this now becomes equal to, this is minus, integration of minus x square is how much? Minus of x cube by 3. Limits. The initial point, the path starts at I. At I, x value is nothing but -1, and final point is nothing but 2. And when you substitute the limits, what do we get? 2 cube is nothing but 8, and -1 whole cube is -1. 8 minus of -1 is 9. 9 by 3 is 3. So we have the result of integration as nothing but -3. Okay. So this is what we have here. Yeah. So let's go for the next question. This is, but notice this is a question of open path integration. In open path integration, this is the procedure. From equation of path, write everything in terms of one single variable. I'm writing y in terms of x here, dy in terms of again x here, and then I'm taking f dot dl and converting that f dot dl into one single variable. Okay, that's what we have done. Initially, I've got y dx minus x dy, and when I substituted the equation of the path here, I've got everything in terms of one single variable. So I've got the integrand ready for me right now. But you have to also properly identify what is the initial point and final point. The initial point is nothing but the point where the path starts. So the arrow mark direction will tell you what is the initial point and what is the final point. At the initial and final points, now the integration is with respect to what variable? X. So what is the value of x at the initial point? At the initial point, x is nothing but -1. At the final point, x is nothing but 2. So you are writing everything in terms of only x here. That's it. Okay. Yeah. Next. Yeah, again line integration of a vector, can say function or vector field along a straight line. Here the equation of path is not given to you. Earlier I think there was Avinash I think whatever so-called mistake you are doing earlier is actually the procedure you are supposed to follow here. Okay, so you have been given first point, second point. By using this, I require the equation of the path. Earlier the equation of the path was directly mentioned for me, y equal to x square, equation of the path along which we are performing the integration. So I don't have to trouble myself in getting this y equal to x square equation. I have already got that. But here I don't have the equation of the path. I have to first of all get the equation of the path from this data. Okay, so what is the logic we'll use? Y2 or y minus y1 divided by x minus x1 becomes equal to y2 minus y1 divided by x2 minus x1. So this is the equation of the straight line, right? Passing through the points, x1 y1, x2 y2. Okay. Previous case we require direction. This case we require the equation of the path. So accordingly you do the logic. So y1 is nothing but 0. Y minus 0 by x minus 0 becomes equal to 4 minus 0 divided by 2 minus 0. 4 by 2 is nothing but 2. So we have got y equal to 2x. So this is the equation of the path. Earlier this was directly given to us. Now we don't have this information directly. We have got this by using the given data. Now from this, if I take dy by dx, what is dy by dx here? Differentiation of y with respect to, or 2x with respect to x is nothing but 2 only. So means dy becomes equal to 2 dx. Dy becomes equal to 2 dx. Again, I hope now you understand why am I doing this, because ultimately we are supposed to calculate a dot dl and convert that into one single variable. Hence we are doing this. Next, this is a vector field. The vector function is known as v or u bar, has first and second components. This is ux and this is uy. Coefficient of I cap is nothing but ux, y cap is nothing but uy. So again now I am supposed to do the line integration. Okay, line integration. So let us perform the line integration. For line integration we require a bar dot dl bar. In this case is equal to u bar dot dl bar, and this expression becomes how much? Ux dx plus uy dy. Convert everything in terms of one single variable, and that variable could be x. Everything, let's replace all the y terms in terms of x. What is ux? Ux is 2y. So we have 2y dx plus uy is nothing but x times dy. So wherever we have y terms, we will replace the y terms here. Y term is equal to, according to this equation, 2x on the path, and dy is equal to 2 dx. Okay, so I'm replacing y and dy with respect to the corresponding x terms, and then what do we get? This becomes equal to 2 into 2 is 4, 4x, 2x, 4x plus 2x is nothing but 6x dx, right? So now we have to perform the line integration. Okay, same question. This is also same question. So now integration of a bar dot dl bar I to f in the given case becomes equal to integration of u bar dot dl bar from I to f becomes equal to, what is the integrand now? U dot dl became equal to, I think, 5x, no? 6x. So this is 6x dx. Now the integration is with respect to x. So at the initial point, what is the value of x? At the final point, what is the value of x? So this is x at initial point. This is x at initial point, and this is the value of x basically at the final point. Okay, and yeah, now we are done. This becomes equal to, limits of integration is from 0 to 2, 0 to 2. 6x integration is nothing but 6x square by 2. Limit is from 0 to 2, and this is 6 by 2 is nothing but 3. So 3 into 2 square is 4, 4 into 3 is 12. So basically we have the answer as nothing but, in this case, 12. Okay. Open path integrations. Here again, the initial and final point is not same. So when the initial and final point is not same, you perform line integration by using line integration approach only. Okay, don't apply Stokes theorem whenever the integration is basically a open path integration. Okay. Yeah. Next, this question is neither line integration question nor Stokes theorem question, nothing of that sort. But I have taken this question just to make you understand how data is being given in the recent times. Okay. Yeah, here you have to perform this integration. Yeah, you guys try it out first. You guys try it out over the area of a disk of radius 2 in the xy plane. Okay, so you can assume that the disk is centered at origin. You can assume that disk is centered at origin. So this is the surface. You are supposed to perform the integration over this particular surface. And what is the equation of this guy? This is x-axis and this is y-axis. This is x square plus y square is equal to radius is 2, so 2 square. So you have to perform this integration over this area. Okay, how do you do it? How do you do it? Two square, 4. Okay, so this is one question that you can definitely expect in GATE exam. See here, the data was given in terms of rectangular coordinate system. Okay, so this data was given in terms of rectangular coordinate system. This is just to mislead you. Okay, but if you look at the information that is given here, the surface information, probably the surface information is given in terms of, can I say, cylindrical coordinate system, cylindrical or polar coordinate system? Cylindrical, polar, both are same if it is only xy plane. In xy plane, cylindrical coordinate system is also same as polar coordinate system. Okay. So data was given in terms of one coordinate system, that is the function, and the path information or the surface information is given in other coordinate system. So whenever you see this kind of a problem, always convert them into polar coordinate system only. Don't try to solve the problem in rectangular coordinate system. I agree that rectangular coordinate system is something that you are comfortable with, but the problem was given in such a way that it will be very easy for you if you solve the problem by using the cylindrical coordinate system or polar coordinate system. Okay, so that is the logic in this problem. Okay, so yeah, what you do is nothing but we know certain conversion formulae. So that is nothing but in cylindrical coordinate system, rho square becomes equal to x square plus y square, right? Yes, and furthermore dx dy, this is the area along z cap direction. Okay, let's go back to one of the previous. Yeah. So this is the logic here. The dx dy is also same as rho d rho d phi. So this is the logic you are supposed to use. Okay. Hence I was highlighting this also earlier. Yeah. So wherever you see this dx dy now, in this problem at least, you can replace it with now. Yeah, I can replace this with, yeah. So this is now rho d phi. Okay. So because of that, now I'm converting everything in terms of one single coordinate system. I'm writing this as nothing but integration of what is x square plus y square, that is nothing but rho square into what is dx dy, rho d phi, rho d phi. So ultimately this became equal to now integration of rho square into rho is nothing but rho cube. Integration of rho cube is rho power 4 by 4. So we have now two integrations. One is nothing but integration of rho cube d rho. One more is integration of d phi. And integration of rho cube is how much? Integration of rho cube is, this is rho power 4 by 4. First one, rho power 4 by 4. And the second is integration of d phi is phi. Now, am I covering 360 degrees? Yes. So because which the limits of phi is from 0 to 2 pi. And the radius is nothing but from starting from 0 to the surface, how much is the radius you're having? Radius is nothing but 2. So this is nothing but 0 to 2. When you substitute the limits, 2 power 4, 16 by 4 is 4. 4 into 2 pi. So we get 4 into 2 pi. The answer is nothing but 8 pi. So the problem became simple when you converted everything in terms of cylindrical coordinate system. Okay. So here in this kind of a problems, when half of the problem is given in terms of rectangular, the other half is given in terms of cylindrical, convert everything into cylindrical. Okay, convert everything into cylindrical. Don't do any other logic there. Don't try to solve the problem in rectangular. You will get the answer, but rather you have to spend a lot of time there. Okay. Next, solve this question now. So this xy plane problems you will see a lot. You will see a lot of xy plane questions. So whenever you have xy plane, now that surface, the direction of that particular xy plane, assume that floor plane is nothing but xy plane. Perpendicular to that particular floor plane, what is the direction you are having? Direction is nothing but z cap. Okay, so this is one golden rule that you can take, because most of the problems in line integrations will be mostly given in terms of xy plane. Okay, so normal to xy plane, we have direction as direction is equal to z cap. So means ds bar in this case becomes equal to either dx dy z cap or also equal to rho d rho d phi z cap. Now which of these to choose depends on the rest of the data. Okay, so if you see I'm given a unit circle. Okay, I'm given a unit circle. Unit circle means the data was given to you in terms of the path data at least was given to you in terms of cylindrical coordinate system. So since this is unit circle, equation is x square plus y square is equal to 1 square. So means this is x square plus y square is equal to 1. So it means that rho square is equal to 1. It means that rho becomes equal to 1, okay, on the path. That is what is given. Yeah. Okay, and the vector field is given as, so this expression is nothing but the vector field. So this is a so-called vector field given to us. And now what you are supposed to do is nothing but, yeah, the line integration of the vector field taken in anti-clockwise direction. Here, most people will miss this. Okay, so please focus on this particular direction. Most of the questions will have counterclockwise, anti-clockwise directions, no problem. But when the path is given as nothing but clockwise direction, then you have to be careful. Okay. So let us show the path on a diagram. X-axis and y-axis we have taken. This is x-axis, this is y-axis, and this is the path. This is basically the path taken in what direction? Anti-clockwise direction. So why this is important? Let us see. And what is the radius of this guy? 1. See, curl your fingers in the direction of path. So this is the path C. If you curl your fingers in the direction of path, what is the direction you are getting? The direction is nothing but coming out direction. Coming out direction, is it not also z cap direction? Yes, because when you curl your fingers from x to y also, x cross y is how much? That is nothing but z direction. Okay, so we have x cross y being equal to z direction. In this case is also the direction of thumb when fingers of right hand are circulated along the path. Okay, so curl your fingers always in the direction of the path. So the thumb indicates what direction, please notice that. Now in this case the direction is nothing but z cap, plus z cap or minus z cap, definitely plus z cap. So due to which now I can safely take what is the value of ds bar. So because of this reason right now, ds bar becomes equal to some ds times plus z cap only. Okay, we don't even have to take here minus z cap. Had it been clockwise circulation, now let's assume the path is given as clockwise path, and if you curl the fingers in the direction of the path, then the thumb indicates what direction? Into the board. Into the board means minus z cap. So I will take here minus z cap instead of plus z cap. Okay, so yeah, I've got the vector field. Ultimately in this problem what I'm supposed to solve is nothing but, integration of f bar dot dl bar along a closed path, and we use Stokes theorem here. According to Stokes theorem, this also becomes equal to integration of curl of a bar dot ds bar. Okay, curl of a bar dot ds bar. So let us calculate the curl for the given vector field here, and here we can be saving time. We can be smart and saving time, because already I have got what is ds bar. What is ds bar? I don't know the magnitude, maybe ds. Okay, but direction is what? Direction is z cap. Okay, direction is z cap. So whenever you are calculating curl, you don't have to waste your time calculating x and y components. Directly you can go for only the z component of curl. Okay, so I think we have space constraint. Okay, I want you guys to help me out here in calculating the curl. I don't have enough space. It will be a very simple calculation only. Yeah, I'll do it here probably. Now what is curl expression? Curl of a bar. Now this becomes equal to, we have to take a determinant x, y, z, dou by dou x, dou by dou y, dou by dou z. X component minus 2y, this is minus 2y. Y component is minus 3z, so this is minus 3z, and x component is x. And like I've told here, I only have to take the x component, the z component of curl. So here I'll have some x and y component, something I'll have, I don't care. I only bother about the z component now. What is the z component? Dou by dou x of minus 3z, 0, minus dou by dou y of minus 2y becomes how much? Minus 2, okay, minus 2. So 0 minus of minus 2. Yeah, you do the calculation. Finally, what do we have here? Minus of minus 2 is nothing but 2. So upon substitution, we'll get the data as nothing but, yeah, when you substitute this data here, you get the answer as nothing. Sorry, I don't know what's happening here. Yeah, so when you substitute this data here, what you get is nothing but, this becomes equal to integration of, this is 2z cap dot ds times z cap. Okay, so this is what you get. Most of the cases, you'll get constants. If it is a constant, no headache for us, because I can take it out. Z dot z is nothing but 1. I get 2 here. Integration of ds. What is integration of ds? Surface area. Which surface area? Enclosed surface area. How much is the enclosed surface area here? Area of a circle whose radius is nothing but 1. So this becomes equal to, this is 2 into simply surface area enclosed. Okay, and this surface area enclosed becomes equal to pi times 1 square, and okay, the answer is nothing but 2 pi. So in this case, the answer is nothing but 2 pi. Okay, so what you're supposed to enter here is nothing but 2. So these kind of questions in GATE exam usually are asked as 2-mark questions, line integration questions at least. Okay, wherever you see this kind of line integration, closed path integration mainly, so those questions are generally asked for 2 marks. Okay, another one, I'll show you another repeated model we are having here. This was not a GATE question though, but rather this was a question by IITs only. Okay, notice again, there I have a mixed, I have r also here. R means r square is equal to x square plus y square in our notation. So in our notation, this becomes equal to, okay, in cylindrical coordinate system notation, this becomes equal to rho square is equal to x square plus y square. So whatever is r according to examiner is according to us what? In our notation, this is nothing but basically rho. Okay, and whatever surface that has been given to you is nothing but square. Some extra information is given, is taken around the square of side length 1. Side length is nothing but 1, and center x naught y naught, center x naught y naught, in such a way that x naught as well as y naught value is greater than half. Both x naught value as well as y naught value is greater than half. Okay, so this data will tell that you are basically in one single quadrant. Overall, you are in one single quadrant, because both x and y are in y are basically greater than half. So you either are in okay, you are basically in quadrant number 1 or quadrant number 3. So this will tell you that you can say ki the purpose of this data is nothing but the closed path that you have is in either Q1 or Q3. Doesn't matter where, it is in either Q1 or Q3. Okay, so the purpose of this data is nothing but just to distract you, nothing else. Now look at the direction of the path. The direction of path is nothing but clockwise or anti-clockwise. And sorry, clockwise this is. So this is clockwise path. Okay. When I curl my fingers from x to y, what's the direction of z? Direction of z is coming out, means z direction. Z direction is basically out of the board. And when you curl your fingers in the direction of the path given to you, maybe this is the path called as L, and if I curl my fingers in the direction of the path, the finger point out in what direction? Into. So because of that, in this case, if I take differential surface area ds bar for this becomes equal to ds times, what is the direction? Minus z cap. Okay. Why minus z cap? Why you have got here minus z cap? Okay. Why? Because right hand thumb rule, by using so-called right hand thumb rule. Okay. So you got the direction of ds bar as nothing but minus z cap. That is very important. Okay. Okay. So with this given data, now let us calculate what is the value of curl. And what is the vector field? By the way, vector field is nothing but a bar is equal to minus yi cap plus xj cap. There are multiple ways of solving this problem. One of the method of solving this problem is convert everything into one single coordinate system. Okay, your choice. It's your wish how to solve this question on your own, your method. But I'll show you one method at least. The vector field a bar is given as this is. If you want to solve this in rectangular, you can still do it. There is no mistake because in both methods you will get the same answer. Next, minus y I cap minus y x cap plus x times y cap divided by rho square. This is what is given. But if you remember, this is one of our very commonly occurring vector fields. And what is this vector field in case of polar coordinate system? Earlier we have seen that this is nothing but rho times phi cap. This greatly reduces my problem complexity. Okay. So now I have got this as nothing but this is rho phi cap divided by rho square becomes how much? 1 by rho times phi cap. Okay, so this is what I have got, 1 by rho times phi cap. Now I have to calculate now what is a bar dot ds bar along a closed path L, which also becomes equal to del cross A dot ds bar over the surfaces. But already we have got what is the expression of ds bar. What is the expression of ds bar now? ds times minus z cap. I don't know what is basically ds. We can take the component in, but direction is nothing but minus z cap. So now also I have to calculate curl. So let's calculate the curl for the given vector field. Del cross A. In cylindrical coordinate system, this is 1 by rho into rho cap, rho phi cap, z cap, dou by dou rho, dou by dou phi, dou by dou z. A rho, what is the value of a rho? Nothing is there. Second one is nothing but rho times a phi, and this is 1 by rho. And the last one is nothing but 0. Okay. So ultimately, what about this guy? What about this guy? Rho into 1 by rho, overall this becomes equal to 1. So you are doing some differentiations inside. So whenever you are doing differentiations, you get it as nothing but 0 times z cap. This overall becomes equal to 0 times z cap. When you substitute the data here, okay, so then this becomes equal to, this is now 0 times z cap dot ds times minus z cap. So integration of 0, since this is a bound integration, the answer becomes equal to 0. Okay. So if you look at the options now, yeah, it is the result is independent of integration or independent of point x0 comma y0, because we never bothered about what is the point of x0 y0, and the value is always equal to 0. Okay. So this is the answer in this case, right? You solve it by means of rectangular coordinate system, still you will get that same answer. The answer becomes equal to 0, right? I'm sure most of you are trying by rectangular coordinate system. Yeah, you can try out by rectangular coordinate system. By means of other coordinate system, this is the answer. Okay, this is the procedure in fact. Yes, we'll go for the next question. This is, I think, it looks again crazy. Whenever you look these kind of questions, no, you will be inclined to in fact skip this question and go to the next question. Very simple question this is. So you have closed path, consider unit circle, xy plane. What direction? Anti-clockwise direction. By now, you should have got the logic. I don't even have to draw the diagram. Without even drawing the diagram, by now you should have understood that by combining all these points, ds bar becomes equal to ds times z cap. So ds value is dx dy or rho d rho d phi, that we will see later on. But I know ki anti-clockwise direction on xy plane means z cap. Clockwise direction on xy plane means minus z cap. Okay. And if you look at the data that was given to you, the data, this expression, this is basically a bar dot dl bar. What is a bar dot dl bar in case of a two-dimensional system? So this becomes equal to ax times dx plus ay times dy. So you have been given a vector field indirectly by means of that integration only. What is a bar then? A bar in this case is nothing but coefficient of dx. What is the coefficient of dx? This is sin x minus y, sin x minus y, y cap, sorry, x cap, that is the x component, x cap. And what is the y component? There is a minus sign here. If you send this minus sign inside, we will get x minus sin y plus x minus sin y, y cap. So this is the vector field you have. And what did the examiner ask you? Basically, when you rewrite this right now, we get the expression as nothing but this is basically equal to integration of a bar dot dl bar along the path L. And can I apply Stokes theorem now to solve this question? Yes. Okay, applying Stokes theorem, integration of a bar dot dl bar becomes equal to integration of del cross a dot ds bar over the enclosed surfaces. And what is del cross a here? You have to take curl. So let's take curl. I don't have space here. Okay, again, let's take curl of the given expression. Del bar cross a bar, which becomes equal to x cap, y cap, z cap, dou by dou x. Again, you can be, very smart there in the exam. I have ds bar only along z cap direction. So since this ds bar is nothing but ds times z cap, I'm only concerned about the z cap of curl, nothing else. Okay. What is the x component of a bar? This is sin x minus y is the x component. Y component is nothing but second term x minus sin y. Z component is nothing but 0. I have staggered here. So I'm bothered about only the z cap component. What is the z cap component now? Dou by dou x of this entire term. Sin y differentiation with respect to x is 0. So all you have to differentiate is nothing but only x. 1 minus dou by dou y of this entire term is nothing but minus 1 now. So we have got this as 2z cap. So this becomes equal to 2z cap. Substitute that here, we get integration of 2z cap dot ds times z cap, which becomes equal to z dot z is nothing but 1, 2 into integration of ds. Integration of ds is surface area. So this is 2 into surface area. And this becomes equal to, what is the surface area? So now we have a unit circle. Unit circle surface area becomes how much? Unit circle means it's a circle whose radius is nothing but 1. So pi into 1 square since unit circle. So this is pi. So overall we have the surface area enclosed as nothing but pi. So in this case the answer is nothing but 2 pi. Okay. So these are very well 2 mark questions. Usually these are given as 2 mark questions. Okay. Yeah. Let's go for another question. Nice question, another question. This is also a good question. Again, contour is given. You have to calculate f dot dl. Look at this vector field. This is our very common vector field given to us. Okay. Now in this case, no, solving this is not a big deal. Okay. So f bar is given as, this is y x cap minus x y cap. So again we have to perform closed path integration. We can clearly see the value of integration, closed path integration means we will have to calculate curl first. I'm calculating that. Okay. So we have x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. X component is y component is minus x, there is no z component. And entirely, if you notice, we are in xy plane. Xy plane, what is the direction of the circulation? Anti-clockwise or clockwise? Anti-clockwise. So here I can see the path is anti-clockwise. So since this is anti-clockwise, ds bar will be along what direction? Ds times less z cap direction only. Okay. I am only bothered about the z cap component here. So what is the z cap component here? Dou by dou x of, when you take only z terms, dou by dou x of minus x is nothing but -1, minus of dou by dou y of y is 1. So finally we have here minus 2 z cap. So this is our del cross f. So you are supposed to calculate integration of f bar dot dl bar along the closed path L becomes equal to, by means of Stokes theorem, del cross f dot ds bar, which also becomes equal to integration of minus 2z bar, because the curl expression we have got is nothing but minus 2z cap dot ds bar. What is ds bar? ds times z cap becomes equal to minus 2 into z dot z is 1, integration of ds is nothing but surface area, minus 2 into whose surface area? Surface area of the triangle. Okay, surface area of a triangle. What is the surface area of a triangle? It is nothing but half times base times h. Here, do I have the information of base? Yes, this is 0, 0, this is 2, 0, means this is 2 units. Angle here is 45 degrees, pi by 4 is nothing but 45 degrees. So this is 45 degrees. Okay. Total distance is nothing but 2, means 1/2 distance is nothing but 1. Okay. Tan 45 becomes how much? Opposite side by adjacent side. Adjacent side is 1, means opposite side also becomes equal to 1. Okay. So this is from the given data, and by using this 1 given to us as well as 45 given to us, we are calculating this particular one. Okay. So means now I have base value for this triangle. Base value is nothing but 2, and the height of this triangle is also equal to 1. So they are also testing your geometry skills. Okay. So yeah, 2 into triangle area is nothing but half into base is 2 into height is equal to 1. So finally we have minus 2. So in this case the answer is basically minus 2, right? Yeah. Let's go for another question. Yeah. Again, if you look at this vector field, it looks same as compared to what we have done in one of the problems. Minus y x cap plus x y cap divided by x square plus y square. It's kind of one of the previous problems. Yeah, minus y x cap plus x y cap plus divided by x square plus y square. Same kind of a problem. Okay. So here, whatever you are supposed to calculate is reverse of the curl. You are supposed to calculate del cross E dot dA bar over the hemispherical surface is dash. Okay, so this is the question given to you. This requires a little bit of visualization. Let's assume this is basically the equator. Okay, so hemisphere is given to you. This is basically the top surface. The top surface I will call it as nothing but some S1. Okay, and you can see here also there is another surface. This is the second surface that you have, which is basically a circle. So this is basically a circle. Let me call that circular surface as nothing but S2, or circular, or a disk to be more precise. No, we have to call it as a disk, circular disk. I will call it as disk. This is basically disk. Okay. And if required, you can also take this closed path. Let me call this closed path as nothing but L. So this expression is the right half of the Stokes theorem, right? So what examiner asked you is nothing but, they asked you what is integration of del cross E bar vector field dot ds bar over the surface, and that surface is hemispherical surface, and hence I'm calling it as S1, right? So by applying Stokes theorem, can I say that this is also equal to E dot dl? So is it not equal to also E bar dot ds bar? Yes, over the path L, because yeah, enclosed inside this particular closed path you are having this hemisphere also. Yeah, you are having two surfaces. This is one surface, and if you extend that, if you pull that particular surface out, maybe let's assume that this blue surface is an elastic surface, you are pulling that out, then you are having this hemispherical dome. So you are calculating this part by applying Stokes theorem in reverse, we'll have this expression. Again, when I apply Stokes theorem, is it not also equal to integration of del cross E dot ds bar over the surface S2 also? Yes. So over the surface S1 over the surface S2, it will give you the same answer. But rather, using the hemispherical surface for calculation here will take a lot of time for you to do the calculation. So what you can do is nothing but you can nicely go for the surface S2. Okay. So this part is also Stokes theorem. And this part is also basically Stokes theorem only. Okay. So me, instead of going for this hemispherical surface, I'm going for circular disk. The only difference here is nothing but S1 is basically hemisphere, and whereas S2 is nothing but circular disk. Okay, circular disk. So yeah, so I'm modifying the problem into now a problem of circular disk, not a problem of hemispherical surface now. Okay, so let's take the data. The vector field E bar is given as minus y x cap plus x y cap divided by x square plus y square, which is also equal to, in case of polar coordinate system, minus y x cap plus x y cap. Whenever you see this, you can write it as nothing but rho times phi cap divided by, denominator is nothing but rho square. So by means of point conversion, you can write it as 1 by rho times phi cap, right? Yes, this is what I have right now. Now, like in the previous case, I have to calculate now curl del cross E. This becomes equal to 1 by rho into rho cap, rho phi cap, z cap. I'm using now cylindrical coordinate system expression, dou by dou rho, dou by dou phi, dou by dou z. Here I don't have any rho components, 0. So this is rho into the phi component, 1 by rho. There is no z component. So this becomes equal to 1 by rho, rho cap, rho phi cap, z cap, dou by dou rho, dou by dou phi, dou by dou z. This is 0, and this is constant 1, lastly 0. And how much is the curl now? Curl becomes equal to 0. Okay. So finally, what is del cross E? If you want to calculate del cross E dot ds bar integration over surface S1 or S2 right now, or S2, in both cases right now at least anyway, it becomes equal to 0. Okay. But if it is not 0, okay, in that case, what to choose, S1 or S2? Choose always S2 here, not S1. If you choose S1 hemisphere, again you have to convert the cylindrical coordinate system into spherical, or the original rectangular coordinate system into spherical, which will be a very lengthy process for you. And ultimately, whatever answer you get there and here will remain same. But only thing is here, the answer will become very simple for you. Okay. So I would always suggest, if it is a non-zero value, if this is a non-zero value, okay, if curl is non-zero in this case, so then perform the integration. perform the integration over S2. S2 which is basically a circular disk. In this case S2 means circular disk, S1 means hemisphere. Don't solve it over hemisphere, solve it only over the circular disk. Okay. Yeah. Okay, so this is where I'll close this session. So in this session, it's mainly about the surface integrations as well as line integrations and the application of gradient and the background study of coordinate geometry. In tomorrow's session, we will start with the actual EMF portion, which is electrostatics, magnetostatics, Gauss law, Ampere's law. So all those discussions we will do it tomorrow. Okay, tomorrow we'll have another marathon, which is specific to core electrical syllabus, and day after tomorrow we'll have a specific marathon for EC syllabus. Okay. Yeah, so we'll close this session now. We'll again meet tomorrow. Thank you. So if you have any doubts on what we have discussed today, I'll be happy to answer your doubts. Yeah. Okay. Okay then guys, we'll yeah, guys, there is a session on power systems also, and it will be after 20th. Okay, session on power systems as well as machines will be after 20. Okay, for EC guys also, tomorrow's session will be greatly helpful because Gauss law and Ampere's law questions still you will get. Okay, it's not that you don't get questions on Maxwell's equations. Okay, Gauss law, Ampere's law are giving us Maxwell's equations. Apart from that, we'll also discuss about the conservative as well as solenoidal nature of magnetic field. Again, a part of EC syllabus. Last year, if you see, one of the 1 mark question we have was which of the following is electrostatic field. We had some 4 options, two vector fields, and we have to identify which of them is basically a probable electrostatic field. Okay, and to answer those kind of questions, again tomorrow's session will be helpful. Tomorrow's session, even though I'm saying it's core electrical, it's also a part of EC syllabus by default. Okay. Yeah. Okay then guys, we'll call it a day then. PDF I'll upload it. Okay, I'll share the PDF link with you and also the password with you. Don't worry.